everyone, welcome to a SQL Full Course by Simplilearn. Have you ever wondered how websites, apps, and businesses manage huge amounts of data? The answer lies in SQL, which is structured query language. It's the key for organizing, managing, and analyzing data, making it an essential skill for developers, data analysts, and database experts. As data becomes the foundation for smart decision making, SQL skills are in high demand everywhere. So in this course, we'll start with the basics and walk you through a complete data analyst roadmap. You'll learn how to use SQL for data analysis and dive into topics like entity relationship diagrams, normalization in SQL, joining tables, UML use case diagrams, PostgreSQL, and also learn how to work with SQL CTEs, which is common table expression. And we will wrap things up with a hands-on SQL project for data analysis and go over to SQL Interview Questions to help you prepare for real-world scenarios. And by the end of this course, you will be equipped to manage and manipulate data like a pro. So let's get started. Before we commence, if you're interested in professional certificate course in data analytics, begin your learning journey with Simplilearn and IIT Kanpur Data Analytics Certificate course. Explore a learning management system, track your progress, and meet completion requirements. You learn to understand data and enhance your analytical skills through live sessions with industry experts, hands-on lab, and masterclasses by IIT Kanpur faculty. So hurry up and enroll now and find the course link in the description box below and in the pinned comments.
Today we will learn SQL Basics. SQL is the spine of data analytics, whether you are trying to store decades old of data or retrieve a row from racks of relational databases capable to store petabytes of data. SQL is always your best tool. So in today's session, we will learn the basics of SQL through a small use case. So here is the context. Imagine you're a SQL developer, and as a SQL developer, you face a critical issue during the project. Your client runs a huge restaurant and now is eager to expand his franchise. He has a couple of questions, and these are real business questions through which he can understand the performance insights, like the best-selling products and increasing their inventory, offering memberships and discounts to frequent customers, and much more. This would automatically help the client to reach greater heights in business. Now, let's switch to the MySQL workbench. Now we are on MySQL workbench. Now we've already created a database. So let's start with use database name, which is SLP. Use the Control Enter shortcut to access your database. Just in case if you haven't created your database, just go to the schema section, right click. It should look something like this. Here you can create a new schema. Create schema, and you can name the schema and proceed. Let's say sample, and then select apply. And here you can check some other priorities or parameters. Let's say if you want to lock it, you can. But now let's proceed with the basic default one. Apply, and a new schema has been successfully created. Now you can close this one. And let's say you don't want a schema, then you can go to the schemas here. And let's say I don't want car dealerships, you can just delete the schema by pressing drop schema. Now that we have a brief understanding of how schema works, now let's proceed with creating data tables and loading data into it. So there are multiple ways. Let's say you want to create by manually typing in the code. You can do that. Let's proceed with that one first. Now our tables are a little bit too long. We'll be using 5 different tables here. So to create any table, basic priorities are you need to use the keywords create and table, and after that the customized name for your table, and followed by that the column names that you want to have in your data table along with their data type. So user ID will be integer data type, and create date will be data type, and product ID will be int. Similarly, to insert the data, you need to use the insert keyword and into keyword. Now you need to provide the specific table that you have created here. So you have created sales table. So you have already added the sales table name here and the columns user ID, created date, and product date, which are over here. And next, the values. You need to enclose the entries in parentheses. So integer will not have any specific single quotes or double quotes, But if you are adding any data which is character based or date based, time based, then you need to encode that within single quotes. And after that, the product ID. Now we will have a separate table for product as well. Remember, by the end of all your entries, provide a semicolon which indicates that is the end of all the entries for your data table. Similarly, we have also provided a semicolon here, which is telling SQL Workbench that it is the end of creation of a data table. And these entries or these column names are enclosed within parentheses. Now here we have a product table with similar entries or columns and also similar entries following the priority or parameters, which will include insert into and values keywords and also the column names which you created and so on. So these will be our data tables. Now let's quickly run all these commands and create the data table. There you go. The table has been successfully created and the entries are also inserted. There's a small mistake at row 1. If you go to row 1, let's check what might be the issue. So the problem is with the date value. So SQL Workbench follows the date value, which is year, month, and date. So here, while I was writing the dates, I entered date, month, and year. So we just need to correct it. So now that I have corrected, let's try to run it once again and see if it works or not. There you go, it works. Now let's proceed with creating the product table. It's created, and also the product menu. Followed by that, we have user data. And when it comes to users data, we have two different users data. So one is regular users, so including all the users from day one. So out of all the users, a couple of users, if let's say if we have about 10 users, a couple of 5 or 6 users preferred to take golden membership, or let's say in our perspective, the customer or the owner identified these customers to be most valued customers, or they are the ones which frequently visit the restaurant and order good bills and etc., right? So he kind of sells them premium golden users sign up. So here it is. So they buy the golden users sign up. So now let's proceed with that. And here you can see I've got the data corrected for this one as well. So we have created the table users. Now let's enter the data for users. There you go. The data has been entered to users. And now we will also create users names data table, which will have the details of users and enter the details. And lastly, a few of those users who chose to buy the golden users sign up or being offered by the client or the restaurant owner, right? Enter. And last table, the entries for these data table. Now these were the data tables. Now let's also validate or fetch the data. So we have about 5 data tables, right? So let's mention them here. 1, 2, the rest. So these are the data tables. For fetching the data, you need to use the select command and star for selecting all the columns. But let's say if you had a specific column to extract, then you can mention that specific column name from data table, right? Now I want all the data columns. So select star from table name and semicolon to make sure that the SQL Workbench understands that is the end of your command. Let me provide the same command for all the tables. There you go. Let us run. So these are the entries. Similarly, next one, these are the entries. There you go. 4th table. And lastly, the 5th table. Now, you understood how long it is. But let's say you already have all these data tables existing as a SQL, or let's not consider SQL database. Let's say we have this information in Excel table. Then what you can do is you can just directly extract that data, right? So what you can do is just recently we created a sample database, right? Let's try here itself. So we have, let's say we'll go with car dealership data as well. And here you have the tables. Just right click and here you got the option import data wizard, table data import wizard. And now you need to just provide the location of the data. So I'll have some Excel sheets somewhere. Let's go with Excel datasets, and I have some customer data here, and I'll open it. And now you go to next and next. There you go. It'll give you the information. It'll let you decide the data type as well. So I'm currently okay with all the data types. For row ID, I'll go with int, order ID, text, order date. If you want to change, you can go into the data table options and provide date time, right? So, we also have ship date. You go with the date time option for this as well. Order date and ship date, ship mode, and so on. Check all the other columns. There should be a delivery date as well. I think we already made that. And it also assumed that it'll go with double for price, discount, and all other options where you might have decimal inclusions, right? So you can either go with float or double is also good. There you go. Now I just need to check on next, import data table. Okay, you need to press on next. It'll start preparing import and imported file. Click on next again and finish. Now if you click on tables, you can see your customer data table is readily available here. All the columns, if you press on column, let me expand this a little. So all the columns you're looking for, order date, state, region, everything, it is readily available for you, right? So these are the easier ways to either create the data or import the data for your SQL workbench. Now, let's proceed with solving the questions. Let me change the orientation. Let us go with this one. There you go. And let us also expand or increase the font size for the better visibility of code. Now, let's proceed with all the questions. We have about 15 to 20 questions. And here you can see I've used this particular symbol to make sure that SQL Workbench understands that this is a comment. Right? You can write comments in both the ways. You can choose to just double hyphen or slash star and another star and slash. This will make it a comment. Now let's proceed with answering the questions. What is the total sales revenue generated by each product? Now the question was, what is the total sales revenue generated by each product? Now he wants to identify the total number of products available in his inventory, and he wants to sum up the total number of orders received and sum the price according to the orders received. Let's say he have about 5 items in the menu and each item got about 2 to 3 orders and into the price, and he wants to know the profit. So for that, we might have to join 2 different tables. So the product details are in the product table and the sales details or the price details are available in the sales table. Now we will select product name. So I've recognized product table as P here. So what this will do is it will act as an alias to product table name, and it is specifying SQL to understand to avoid ambiguity and go to the product name which is available only in the product table. And here we are using the summation operation as the aggregate operation to sum the total price, and it has been aliased as total sales revenue. So you can alias the resultant column name using the keyword as, and you can give a customized name. In our case, I gave it total sales revenue from sales data table, and I've aliased it as simple letter S. And coming into join operations, we are performing a simple join operation here to product table and the sales table based on the common column between both the tables, which is the product ID, and we are grouping by product name. Now let's run this and see the output. There you go. And in case if you wanted to order it by increasing order, right, highest one on the top, then you can also use order by product name, not product name, sum of price, or you can use the alias name as well. Rerun it. So by default, it will take ascending order. So we need to provide descending. Now you have these items which were on the highest sale. So these are the products which gave him the highest number of orders and highest profit. So he needs to focus on improving inventory for these products. Now let's switch to question number 2, which is which 3 products have the highest sales revenue? In talks, we already solved this question. So order by, what you can do is, he's just asking about the 3 products, right? So we can give him the result of only 3 products. For that, you just have to paste the same code, enter limit 3. Now what this will do is it will yield in result with only 3 rows. So you'll get only these three entries as a result. There you go. So he needs to focus on these products. So how many users have signed up for the service and has taken the gold membership? Now let's try to solve this one step at a time. So there are 2 ways to do this. Basically, you can just count the number of user entries from the golden users sign up table, or the other way around. Now he wants to understand out of the total number of customers, maybe around 10 to 15, he wants to know the ones which have taken the subscription. So let's go with the second approach, where we'll try to combine both users table as well as golden users table, and we will specifically match the user IDs which are in both golden users table and users table. Basically, let's say there are 2 approaches. You enter the restaurant today, you like the food, and you like to take up, you like to become a user of that customer, but you straight away go to the golden user membership. Some rich people do that, right? And the other way is you might be just a common user, then you just like the food over and over, and then you turn out to like it a lot that you prefer becoming a golden member, right? So there are 2 types of approaches. Now let's count both of them and try to solve it. So what you will do is, we don't want, let's say if you want to count the user ID from golden user sign up, there might be entries where user ID 1, which is a golden user ID, might have, appeared multiple times in a row. So you don't want to count that multiple times. You just want to count the distinct ones. So once if you counted the number 1 or user ID 1, you'll leave it if it is repeated. So we will be using the distinct keyword here and count aggregate function, and you will alias the name of the column as gold members from golden user sign up, and you will join users table and you will alias users table with an alphabet U on golden users ID is equals to users ID. Now let's run this command. There you go. And the count tells us 5 entries are there in the golden members. Now let's proceed with the next question, which says what is the revenue generated from gold users. Now you need to kind of join tables here with golden users data table as well as sales and users. So you have 3 tables basically. So you need to identify golden users, identify their user IDs, and you need to match every order which was placed by golden user IDs, and also the product. Yeah, you also need to join the product as well. So product is the table where you have the details of the product which are being ordered by the customers, and you need to also check the price which is available in the sales table. You need to join all these 3 tables and sum up all the pricings for the orders they placed and give the total number of revenue they generated. Now let's deal with this. We have the analogy in our mind. Now let's write the code. So here I have selected the price as well as we are performing some joins with golden users, product, etc. Right? So using the aggregation function, which is sum, to calculate the total pricings these particular users prepared or bought from the restaurant, and we are aliasing this particular column as gold users revenue from sales table. Now we are performing a simple join on golden users sign up as well as users table, and also the product table which has the product details. Now let's run this particular command. So overall, the golden card or golden sign up customers gave about $4,690 of revenue to this particular restaurant. Now proceeding with the 5th question, what is the total revenue generated from gold users? I think the question is repeated here, not to worry. Let's proceed with the next question, which says which users have been a gold user for how much of time? Now this particular question is a little bit tricky. So he's asking about the users which were actually regular users before, and on timely basis down the line, they converted into gold users. So how much of time, right? Which users have been a gold user for how much of time? So you need to evaluate the users first and then identify on what date they were registered and what date they became a golden user, and so far how much time they have spent being a gold user, right? So let's start to write the query for this. So there you go. We're selecting the user ID column for golden users table. So we have aliased it with G alphabet, as well as we're using current date function and date def function. So we are trying to subtract the sign up date. If you check the data table of golden users, they have the user ID as well as the sign up date. So we are subtracting the sign up date with current date, and for that we're using the date def function. And we are aliasing it as days as gold user from golden user sign up. Now let's quickly run this query. There you go. So I think this data is a little bit older, maybe around 2014 or 2015. So it's been like years. So it calculated the number of days. So these are the ones. So maybe 2014 or 2013 as well. So the 2014, 2013. So those many number of days they've been a golden customer. So they are kind of really loyal customers for this particular restaurant. Now, what is the most popular product among all golden users? Now, this particular question is again a little bit drilled down. So so we have found 3 top selling products, right? So now he wants to filter out the golden users only. He wants to know each and every golden user, what is the product they have ordered amongst all the orders from golden users alone, which is the highest selling product. So he wants to take care, or I mean to say, take special care of the golden members. So let's try to investigate that. So there you go. We wanted the product name as the first column, second the product ID, and we also want the product name. So the product name is present in product details, and user, the golden users, the details of golden users is present in golden users table. And we also want the product name, which is only available in the product data table. So to map it, you need to prepare a join in between 3 different tables. And after that, you need to group by product name and order by purchase count, right? So, and we also need only one row of it. So we're limiting to the one resultant row. Let's run this, and there you go. So in premium customers, Shahi Paneer is most ordered and the purchase count is 7. Now proceeding ahead, which is the 8th question for today. What is the total sales revenue generated in each year? So he wants to know year on year growth of this particular industry or restaurant. Let's run or write a query for that and run it later. So for this, we're using the datetime function again. Now we have a column which is created date, like the customer creation date. So we are taking it and we are splitting it in terms of years using the datetime function, and we are aliasing it as year, right? And apart from that, here we have sum of prices, total sales revenue from sales, join product and product ID, and group by year using the created date, right? Now let's run this command. There you go. So in the year 2017, we have 1940, 2019, and so on. You can also try to sort these numbers in a descending order, which is, I think, already kind of done. No, it's not done. So you can also order this by the year, or so this can be done using this particular column here. You can order by year. So let's take that as a homework for you. And so far, so good. So this way you can identify what is the sales growth or revenue generated on yearly basis. Now we will be proceeding with the 9th question, which was the same which we discussed before. We just wanted to order it in terms of years, right? So just kind of, you got the homework right here itself, order by year, and maybe you can also provide the SC in the descending order. Now let's run this command. There you go. So in the descending order, 2020, I think the data is about 4 to 5 years old. So here we have it, 2020, 2019, 18, and so on. Now the next question. So the next question is the 10th question. What is the average gold sign up compared to just sign up for users? The thing is, what you need to do is you need to check the intervals. the interval between the current date as well as the last sign up dates, or the what's the interval between, let's say today one user signed up just for normal sign up, and after 10 days another sign up comes in. So basically he wants to know the frequency of average frequency of sign up and compare it to average signups of gold signups. So here we will be using average aggregate function alongside with the date def function, which is a date time function. So here you are just giving the difference between sign up dates and gold sign up dates. So the users, you'll be joining the table with the users, and you will be finding out the average date difference between the gold signups and the normal signups. Run this query and see the output. So before we run, so you can see there are multiple select statements here. So it's like a subquery. So what we are doing is we are trying to select already filtered columns in this particular part, and we are aliasing this as average gold sign up time. So whatever the extracted part of this query is aliased as average gold sign up time, and inside that you also see another subquery which selects the date difference between the regular sign up time, and it is all combined and encapsulated inside the external select statement. So this is a brief introduction to subqueries in SQL. So now let's execute this. So there you go. For the average gold sign up, the average days is 1021, and the average normal signups is like 3071. Because we are comparing this to the current year, current date, and the data is about 4 to 5 years old, we can see a huge gap or interval between the signups. But say we are in the same 2020, or say the restaurant is still running current date, then it might be a little the frequency would have been reduced a little. The number here, the frequency seems to be a large number, and you might almost think there are no signups happening these days, but it's not like that. If ever we had the latest data, let's say we add the new data into the database, then we will have new updates here as well. So I think we got this sample data from the client, so he just wants the sample codes, and whenever he updates the data, I think he will have a complete overview of what he's looking at. Now, the next question, which is question number 11. So, how many gold member users have ordered how many number of times? So, let's imagine today someone from the users group decided to upgrade to gold member, and now the client wants to know how many number of orders that person has placed from today, or let's say a week before somebody got upgraded to gold member. Since that day to the current date, how many number of orders did that person have ordered? So in the previous questions, we found it like we have about 5 gold members in the restaurant. So he wants to know how many number of orders did gold members pay. Now let's write the query for that. I think we might have to club sales data, and we might have to club with gold users data and the product data as well. Now, maybe product we will see down the line. I think sales and the gold users should do. Let's try to write the query. So the query seems a little easier. You just need to make sure you consider the user ID column and count the number of product, or product ID, the number of products he ordered as order counted from sales. So we have a product ID column in sales, and you can just, or in place of product ID, you can just place a star. You basically have to count the number of rows which are belonging by the gold users, and then group by the golden user ID, right? So let's run this and see the output. There you go. And in case you wanted to find out the best or the highest orders candidate, then you can give it by this particular one, or you can just copy the alias and paste it here, and descending DESC, find out user ID 1, the guy from the premium, got so many orders. This is the highest number, right? So let's check here. There you go. Now let's move ahead with the 12th question. What is the total amount each customer spend on online food delivery? So now I think we have about 10 users, 10 customers, and now the client wants to know what is the total amount they spent on his restaurant from day one. So this is quite simple. Let's try to answer this query. So basically we have user ID and some sales data in sales table. But to get the exact price of each product, we might have to link up with the product table as well. So we want to know how much amount they spent, right? They in the sense the customers. So we want to know customer number 1 paid how many number of dollars, customer 2 spent how many number of dollars. So we also have added the user ID column here. And the next column would be the total price they paid till date. So we will be using a sum aggregate function on price, which we will be getting from the product table. So we have placed a join there, and we will also group by user ID. And I think we can also order by, so that we can find out the most loyal customer, and we will write it down as order by. And now let's run the query. There you go. So the person, okay, let me do it as DESC and run this again. So the person, user ID 1, has paid the highest total amount. So he paid highest bills, $1,350. There you go. Now proceeding ahead, we have the 13th question. What is the frequency of customers' visits to online platform? So it is a little similar to this particular one that we preferred or solved here using time date functions in the question number 10. Now it could be a little similar here. Let's try to solve this question. Find out the frequency of customers to online platform. And he did not mention if we are focusing on normal users or if we are focusing on golden card users, right? So we will be dealing with the sales table as well as the customers table. So you can see we have two different customers table. One is users and another is golden users. So far, after executing so many queries, we found out that the group of people who are in normal users are the ones who prefer to upgrade to golden users, right? So I think if we just match up with users table, we will be good enough. So we will join along users table as well as sales table, and we will find out what's the frequency of online orders using the time date functions. Let's proceed with that. So there we have it. We will select the user ID column and we will count the order created date, and it will be renamed as visit frequency from sales data table. So I think we don't have to go through the customer specific data. I think we will be happy with the sales data alone. So now let's group it by user ID and run the query to see the output. So on a regular basis, the frequency of customer ID 1 is 7 and remaining all is so along. 3 is 6, 2 is 3, 4 is 2, 5 is 2, and so on. Now let's proceed with the next question. What is the first order purchased by each customer? Again, it is kind of date and time function related. So when they got registered, the day they got registered and after the registration, what was the first product they ordered from the restaurant? So this is what we have to find out here. Now let's proceed with answering the query. So here we go. So we will be selecting the user ID column. Along with that, we will be selecting the created date, the date when the registration or the customer was created, signed up. So that is the column we are selecting. And we will be using an aggregate function where the date is minimum. And that day will be the first order date from the product name, and from sales, yes, right? So we will be joining the product table to identify the product name. If you check the sales data, you just have the product ID there, not the product name. For that reason, we will also join with product data so that we can match the product ID from sales table with the product ID from product table, and where they match, we will check the created date should be equals to the minimum of the date when they got registered from sales table, and user ID is equals to sales user ID group by sales user ID plus product name. Now let's run this query. Control enter, and there you go. So the first order date for user 1 was 2016 May 20th, and he ordered Shahi Paneer, and so on for all the individual customers. Right, now let's proceed with the 15th question. What is the most purchased item on the menu, and how many times was it purchased by all customers? So it might be a little ambiguous. So you might have vegetarian customers as well as non-vegetarian customers. So let's say there is a high frequency of non-veg item, then a certain customer might not have bought it. The vegetarian customer might not have bought it. So there are multiple ambiguous situations here, but still we'll try to answer that. So we will be basically counting the total count of orders made, product name, and sorted by total number of orders they placed. Now let's try to execute this query, and there you go. So we have identified the most sold item and how many times that each customer have bought it. So here we have limited it by 1. If you eliminate it, then let's say we will get all the details. So all the details of all the items which were ordered by every customer. So I think Shahi Paneer was also ordered by some non-vegetarian customers, and this is equally the highest number of or highly found out recipe in this particular restaurant. So this was highly sold to all the customers. They prefer this one. Now proceeding ahead, which item is the most popular for each customer? So everybody has their own special choices. So somebody might have ordered maximum number of Shahi Paneer, somebody might have ordered maximum number of gulab jamuns, all right? So we will find out on an individual customer basis that which was their favorite or most popular dish or recipe. Now let's proceed with writing a query for this one. So basically we will select the product name first. We'll select the product name column, and we will count the total number of purchases of each and every item on the product menu, and then we will map it to each and every user, right? We will find out the count of all the products ordered by every person, and then select the maximum orders. Let's say user 1 comes to the restaurant, he orders gulab jamun for 10 times, Shahi Paneer for 20 times, and some other recipe for about 15 times. Now, out of all these, gulab jamun, which was ordered 20 times, will be selected. So that's our approach, which is here spaced inside a subquery, and this is named as a subquery. And then we will find out with the condition where subquery.userid is equals to sales.userid. Now let's execute this, and there you go. So user 1 had his favorite, which is our Shahi Paneer, and Dal Makhani for user 3, user 2, which is butter chicken. Now instead of user IDs, you can also make some modifications to this particular query and identify user name as well, right? Now let's proceed with, maybe you can take it as a homework and let us know in the comments if you were successful to extract a user name as well. You can just add a user name column here, and along with the user ID, you'll get the username as well. Now let's proceed with our next question, which is 17th question. Which item was purchased first by the customer after they became a member? Brilliant. So there are more instances where you just visit a restaurant and then order food, eat, and come out. If and only if you preferred, like the taste, that's when you try to become a member, right? So before they actually became a member, just visited the restaurant and just ordered something. So they want to know which was that specific item. So the client here wants to know which is that specific item which made them to become a complete, lifetime member to that particular restaurant. So make sure that he wants to make sure that that particular item will stay on the menu for long durations so that he can attract more customers. That's the analogy behind this particular question. Now, let's try to answer that. So there you go. We will pull out the order ID, customer user ID, and product name, and we will make sure that the created date is minimum, which is the first order. This approach is similar to the previous one, and even we are calculating the gold user sign up as well and the product name, and we will just try to extract the result out of it. Now let's try to run this. Shortcut key, which is Control Enter. There you go. So user ID 3, before they became a customer, ordered dal makhani on the specific date, whether they became a customer or on the date he ordered this one, and it made him like the restaurant, and then he became a member, right? So this was the information which the client wanted to know. Proceeding ahead, we have which item was purchased before the customer became a member. I think which is a little relevant to the previous question. Maybe it is a repeated question. Or let's identify which item was purchased before the customer became a member. Yeah, this is similar to the previous one. Now proceeding ahead, we can just eliminate this question as repeated. And proceeding ahead, we have the 19th question, which is about what is the total orders and amount spent for each member before they became a member. Okay, this is a little similar to the previous question, but here they want to know what is the total number of orders they placed as well as the total amount they spent before they became the customer. So we will have to use the same time and date functions and use the aggregate function minimum where the membership was created along with adding up 2 more columns. So those 2 more columns will be the total orders, count of orders, and sum of price. Now let's proceed with answering this question. So we just copy pasted the same query. All we did is adding 2 more columns, which is counting the total orders and summing up the price they paid. Now let's run this query, Control Enter, and there you go. So you can also order it by the total amount spent, which is I think we already did. So here you have the user ID, total number of orders placed, and the amount. So user ID 1, seriously like the restaurant here. Now proceeding ahead with the last question for today's session, rank all the transactions for each customer whenever they are an XYZ gold member for every non-gold member transaction mark as NA. I think it should be NA. Okay. So he wants to rank all the transactions only of the gold members, and every time a non-gold member is involved in the table, in that particular row, we need to just add it as no, not applicable, something like that. So NA. So let's try and solve this. I think it might take a little effort to identify the solution for this. Let's try it out anyways. So this calls for a conditional statement, right? Maybe like in programming terms, like a switch statement. So whenever we find out an ID, user ID, which is not from golden sign up table, then in that place you can just mention it as the transaction call. You can just mention it as NA if user ID matches or if user ID is equals to or matches with the golden user sign up table, place yes or the transaction details. If not, just type down the text in single quotes as NA. Let's try it out. There you go. Now let's run this query, and there you go. So for customer 1 and a couple of others, we have just termed it as NA. And after he became a gold member, I think we have a transaction here. So yeah, there is a possibility that the customer would have been a normal customer before and he turned out into a gold user. And if ever he had ordered something, then we have his order transactions here. Transaction rank. So in terms of transaction ranks, as the ones we got results before, user 1, he was a normal customer before, but he turned out to be a golden customer. and he was the one with the highest rank and highest number of orders. So there you go, right? And if you wanted to extract this table, you can just, copy row, or you can download the data table. You can export this particular data table and then add a filter to it and filter out all the NA values, and you'll get the golden customers and their ranks. And so far so good. We have answered all the possible questions that we received, and we will be also saving this workbook as a Google document, and it will be accessible for all the learners. And if you want in-depth learning experiences on all the SQL fundamentals like CTEs, join statements, how to load data from different data sources onto a SQL workbench, and case, etc., then we will have those tutorials attached as well. And we have a complete playlist on SQL tutorials. And apart from that, this calls for an end of this session.
According to the industry reports, the global data analytics market is expected to hit over $650 billion by 2029. And that's right, we are talking about a field that's booming faster than ever. And in 2025, data analysts are not just in demand, they are in command. Now, if you love playing with numbers, if solving problems excites you, if turning messy data into meaningful insights sounds like magic, then becoming a data analyst might be the perfect career choice for you. In this video, I've got you covered with the exact step-by-step roadmap to become a successful data analyst in 2025. I'll walk you through the key skills you need, tools to master, real-world projects to build, and we will also talk about all the data analyst salaries, how they grow with experience, what companies pay, and tips on negotiating the best offer. And because I keep seeing these questions pop up online and in Google searches, so I'll also answer the most frequently asked questions about data analytics career. Is data analysis a good career or not? And the best part is, you'll get to learn the free learning resources so that you can start right now without spending a single dollar. So grab a notebook, get comfortable, and let's break down how you can start your journey to become a high-paid data analyst in 2025, even if you're starting from scratch. So let's dive right in. Now, before we jump into the roadmap, let's quickly answer some questions I see asked again and again online and so forums. The first question is, data analysis a good career choice or not? The answer is absolutely yes. Every company today runs on technology, and technology produces data. Analyzing this data helps companies make smart decisions, innovate, and plan for the future. As more organizations rely on data-driven decision-making, the demand for data analysts keeps growing. It's a career that's challenging, rewarding, and constantly evolving, especially with new AI tools and visualization techniques coming in. The second question is, are data analysts well paid or not? The answer is yes. Salaries vary based on experience, location, industry, but data analysts generally earn competitive pay. I'll cover detailed salary ranges shortly in the video coming. Now, the third question which I have seen is, what qualifications do I actually need? Now, the answer is, you don't have to get a fancy degree. Now, many data analysts start with skills in Excel, SQL, and a programming language like Python, plus a portfolio of projects and certifications definitely help too. Fourth question, is data analysis an IT job or not? The answer is, yes, it is. It sits at the intersection of IT and business. While it involves technical skills like coding and databases, it's also about understanding business problems and providing insights to help decision makers. Now let's start with step-by-step detailed roadmap. Now let's talk about what is data analytics with a simple detective example. Imagine you are a detective solving a mystery. Your clues are data, sales numbers, customer reviews, website clicks. You collect the clues, clean them up, and analyze them to find the truth. Data analytics is exactly that, solving business mysteries using data. Now here's a 4-step detective approach. First is descriptive analytics, what happened, like checking last month's store sales to see which product sold the best. The second is diagnostic analytics. This means, why did it happen? Maybe sales dropped because a competitor had a sale. The third one is predictive analytics. This means what might happen next, predicting which product might be popular next season. The fourth one is prescriptive analytics. What should we do? Deciding to run discounts to boost sales. Now let's take an example. For example, imagine a retail company which is trying to understand why sales dropped last quarter. A data analyst would gather sales data, customer feedback, and market trends. They might discover that a competitor launched a similar product at a lower price, causing customers to switch. With this insight, the company can adjust its pricing strategy or improve its product to regain market share. Let's move on to the first step, which is mastering Excel and basic stats. Now, before fancy tools, Excel is your first best friend. Think of it as a digital notebook for data. You need to learn functions like sum, adds up numbers like total sales. The second is you need to learn about average, find average price or rating. Then the third function is if statements. If sales are over 100, mark as good. Fourth one is VLOOKUP. Imagine a giant phone book that lets you find customer information instantly. Then we have pivot tables where you can just have a quick summary machine that groups data and shows total. Talking about the basic statistics, it's just like learning the language of data, understanding average, how spread out data is, and what's normal or unusual happening. Example, if average sales are 100 units, but some days sell 10 and others 200, then stats help you understand this difference. Now let's move on to our second step, which is learning SQL. Talking to databases like a pro. Now think of databases like huge libraries storing your data books, and SQL is the language you need to use to ask the librarian for exactly the books, that is the data which you want. You need to learn commands like select, which gives me, let's suppose, give me all the sales from January, where only sales from New York. Join will give you the combined. For example, instead of looking through every book manually, SQL helps get your information fast and precise. Now let's move on to our third step, which is picking your programming language, which is Python or R. Now programming languages are like detective gadgets, powerful tools to solve complex problems faster. At first we have Python. This is easy to learn. It's just like a Swiss Army knife. We can use pandas to manage data and matplotlib to make charts. Then we have R, which is focused on stats and beautiful graphs with tools like dplyr and ggplot2. You can start with Python if you're new. It's beginner friendly and it is widely used. Let's move on to our fourth step, which is collecting and cleaning data, getting your clues ready. The raw data is like a puzzle pieces covered in mud. You need to have to clean them before solving the puzzle. You'll have to collect data from websites like web scraping, file, APIs, tools that share data between apps or database. Then you need to clean data by filling missing information, removing duplicates, fixing errors. Then you'll need to transform data to the right format, like converting dates into the same style. For example, if one customer's birth date is 1/2/1990 and another one is 1919/1, cleaning makes them consistent. Now let's look at your fifth step, which is analyzing data and visualizing the story. Now it's the time to play detective and find the patterns. You need to use averages, sum, and understand the data. If two things move together, for example, more ice cream sales, then you need to test with hypothesis testing, use regressions to see how advertising affect the sales, and visualization helps turns numbers into pictures. Now tools like Tableau and Power BI make it easy to create charts and dashboard. Python's matplotlib or C help you customize visuals. For example, instead of giving you a boring spreadsheet, you show a colorful chart that everyone can understand instantly. Now let's move on to our sixth step, which is learning machine learning basics. Your detective's crystal. Machine learning helps computers learn patterns from data and make predictions. At first, we've got unsupervised learning. Now the computer finds hidden groups by itself, like grouping customers by shopping habits. Then we've got supervised learning. You need to teach the computer using examples like showing pictures of cats and dogs so it can identify them later. You don't need to be a machine learning expert, but knowing the basics will definitely make you stand out. The seventh step is optional, which is big data and cloud, super tools for huge puzzles. Now, big companies handle mountains of data. Think millions of customers and billions of clicks. They use tools like Hadoop and Spark to break down and process huge data quickly, like having a team of detectives working together. And cloud platforms like AWS and Azure let you store and work with data online. No big servers are needed. Now the eighth step is building real projects and a portfolio. Show what you can do. Now nothing beats practice. Work on projects like grouping customers, buying habits, predicting next month's sales, creating dashboards for easy understanding, joining Kaggle's competition where you solve real. And these projects are your proof to employers that you can do the job. Then you can also apply to Freelancer, Upwork, and you can check in job postings in Indeed and Glassdoor. We also have GitHub where you can find the repositories. Now, the ninth step is keep learning and networking, stay sharp and connected. Now, data is always changing, so keep learning. Read blogs like Towards Data Science, join LinkedIn groups and Reddit communities, attend free webinars and meetups. Build strong resume and get an internship. You can also look for in Indeed and Glassdoor. Now, just a quick information, guys. If you're interested to supercharge your career in data analytics, then the Professional Certificate Program in Data Analytics and Generative AI by ENICT Academy IT Guwahati is the perfect choice for you. Now, this is an 11-month live online course which offers interactive masterclasses by IIT Guwahati faculty and industry experts, combining cutting-edge tools like Generative AI, ChatGPT, Python, Tableau, and SQL. Experience hands-on learning with real-world projects and immerse yourself in the campus environment with a special session at IIT Guwahati faculty. So hurry up and enroll now and find the course link in the description box below and in the pinned comments. Now let's talk about some free resources. Now to make it easy, here are some free places to learn all of these skills. You can go to LinkedIn and check some blogs from there. And then we have Simplilearn's data analyst course, which I've already discussed right now. You can just enroll in that. And we also have Google Data Analytics Professional Certificate from Google, and it's a free course. We also have full courses from Simplilearn. It's a data analyst full course. You can just find it in the comment section below. Then you can also enroll yourself in Kaggle competitions, network and learn from LinkedIn groups, Reddit data science community, and free webinars. Now let's talk about the data analyst salary and career growth. Now that you know the skills and steps, let's talk about the big question. How much can you actually earn as a data analyst? The truth is, data analysts are in huge demand today and the salaries reflect that. So now let's talk about the entry-level data analyst position, which is around 0 to 2 years of experience. So if you're just starting, maybe fresh or looking to switch careers, you can expect around $55,000 to $75,000 per year in US. And in India, you can expect around 6 lakh to 8 lakh rupees per month. Talking about which companies, Google, Amazon, Microsoft, financial firms and healthcare organizations need data experts to make smart decisions. For mid-level data analysts in US, you can expect salary around $75,000 to $100,000 with an experience around 3 to 5 years. And in India, you can expect around 12 lakh rupees to 18 lakh rupees over the experience of 3 to 5 years. Talking about the senior analyst position, senior data, over 5+ years of experience in the US, you can expect around $100,000 till $140,000 plus. And in India, you can expect with 5+ years of experience, around 20 lakhs per annum. Obviously more than this. So let's look at the job outlook in future. So obviously big tech cities like San Francisco, New York and Seattle will offer the highest salaries, but cost of living is higher. The remote jobs are leveling up. Finance, healthcare and AI focused companies often pay more. Getting certifications from Google, Microsoft, Simplilearn, AWS or specialized analytics programs can help you boost your pay scale. So that's your full step-by-step roadmap to become a data analyst in 2025. Now follow this path, practice often and stay curious.
Today we will learn SQL Data Analytics with MySQL Workbench. In this tutorial, we will be going through the fundamentals of SQL that will cover the basic clauses of SQL to the advanced clauses like joins, pattern matching, and much more. For better understanding of the importance of SQL, let's consider a simple use case for our real-time SQL sales analysis for business growth. So, the context. In today's business environment, making data-driven decisions is essential for growth. Imagine a car dealer keen to analyze sales performance and customer behavior to boost profitability. The dealer is eager to understand which fuel types, CNG, diesel, petrol, or hybrid, are most popular among customers. The owner needs data to guide inventory decisions and marketing strategies. This is where SQL becomes a game changer. The dealership database holds the wealth of information, and through SQL queries, the owner can extract detailed insights. Using SQL, the owner gets the number of cars sold segmented by fuel type. With SQL functions, they quickly generate a report showing which fuel types are in highest demand. Armed with this data, the dealership adjusts its marketing strategies, promotes high-demand vehicles, and aligns inventory with customer preferences. The SQL report streamlines the analysis and also forecasts future trends, guiding investment in electric and hybrid models as the market shifts towards sustainability. Now, without further delay, let's get started with our demonstration on SQL data analysis for today. So we will be having two different Excel files. So one Excel file will be having the customer's dataset, and another Excel file will be having the dealership Excel file or dealership dataset, right? And along with that, we will get started with the SQL Workbench, MySQL Workbench data tool to run our queries. I hope I made myself clear with that. Now, let's get started. Now, this is our customer dataset. So our customer dataset will be having order ID, state where the customer belongs to, and the region of that particular state, and his customer ID and his name, right? Along with that, we have another dataset known as dealership dataset, right? Remember this order ID, the first column, remember this, right? When we are performing joins, this is the key based on which we are going to perform the joins with two different datasets, right? Now let's check out the second dataset. So this is our second dataset known as the dealership data, right? So we are having the first order ID, and after that we have order date, delivery days, and dealership name, which particular store is that, and the dealership's PIN code, category of vehicle bought, and product name, quantity, fuel type, traffic, leads, orders, revenue, profit, and basically profit as revenue minus cost to company, right? And the order status, is it in transit, is the order cancelled or placed, or is the order delivered, right? So is it not delivered yet? So these are the order statuses. So we have four different of one of them: order in transit, delivered, cancelled, or not delivered, correct? So these are the two datasets that we will be working on today. And let's also take a look on the workbench that we will be executing the queries on. So this is the SQL or MySQL workbench where we will be executing our queries, right? So currently it is using data from a different dataset. So we don't want that. We can create a new prompt and we can get started with our datasets here. So to get started with the new file, you might have to create a new schema first. So let's create a new schema. So you can just write down your name, car dealership, right? So that's the new schema name. Just apply. So you have just created a new schema. Now let's open the schema here, and you have the tables there, and you don't have any data table, right? So for that, we might want to add a new table. So double click or right click on that, and here you can see a table, import visit. So browse the path, and here we have the dealership data. Open and click on next. And if you go back here, you have an option called drop data table if the table already exists, right? If you already have a dealership data table there, then you can just drop it off, right? And now let's try to make some changes to it because we don't want the confusion. So either what you can do is you can add an underscore, or if you want to keep the space, or you can eliminate that underscore. I'd prefer to eliminate that underscore and click on next. And there you have the data types, right? So if you want to change some data types, you can do that over here. And I think there is some issue with the first one. Here you have order ID with some extra thing which you don't want here, but we can clear that down the line, not a problem. And import the data file, click on next. And there you go, the data file should be shortly imported. It might take a little while, but it's alright. There you go. Click on next, and 1000 records have been successfully included. Finish. And we want another table also to be included. So what you can do is use the import data wizard once again and browse and import the customers data this time. Click on next, and the file name, just make sure that you don't have any spaces, but if you literally want the space, use an underscore but not the spacing, right? It might cause some problem while you're writing queries. That's the reason for which we should either eliminate or use an underscore. So go with next, and here we have the same order ID. No worries, we can change the column name over here, right? It's alright, just import the data, go ahead with it. Click on next and finish. 1000 records have been successfully imported. Now let's run some basic queries like, okay, first we might have to use the dataset, right? So we want to use a car dealership. So car dealership, press enter, or you can use control enter. Okay, there was some spelling mistake. So I think we have created the schema with a wrong spelling, but it's okay. All we have to do is just change the name over here, car. So we have added an extra R there, but not a problem. So we are in the schema now. Now, let's try to run, okay, I'll not erase these names because we'll create a document out of it. So we can select any of the tables. Select, let's look at all the columns. Let's look at, okay, double click, start from, yeah, there you go. We have refreshed it. So if you extend, here you can see customer data, right? So let's type in customer data, semicolon, and there you go. When you run it, you have the data, right? So since we have 1000 rows, we can go with the current 1000 rows, or if you want to extend it, we can go with 50,000, or if you want the whole 1 lakh more than, right? There might be data with more than 50,000 rows. In those scenarios, you can also click on the don't limit option. But since we have 1000 rows, we can continue with what we have, 1000 rows, right? Now let's copy and paste the same command and change the name of customer data to dealership. So I'd like to pass a small suggestion here. So when you're writing the queries, use the keywords in caps, right? So uppercase and data tables or column names in lowercase, so that whenever you pass your queries or your document to your fellow developers, then they can easily identify the difference between the keywords and the column names or the data table names. This will help them to resolve an issue if there is, correct? So we have the table over here. Now we have discussed some issue with the column name, right? Now we will proceed with a quick editing query where we will change the column name of this particular dataset, or no, not just the column, correct? Just a moment. So we will take the help of alter keyword. So alter table, and our table name here is customer data. Before that, let's copy this particular keyword here, or we can do one thing, describe table. We can make use of describe keyword, describe table customer data, enter. Okay, let's find a way to at least copy that column name. I'm not finding how to copy that. Okay, we found a way. Right click or double click, and we have an option of copy field name. Let's copy the field name, and here let's continue with alter keyword, alter table customer data, and let's not use the semicolon here. Now use the rename keyword, rename column, paste the okay, alrighty. So there's the mistake. So we found a way to copy this column name. Just double click or right click here, copy the field name, so that you get the format or you get the exact data which is written as a column name here. There might be some mistake or there might be some problem during the import, but that's not something to worry about. So we are renaming the column name from the existing name to order ID which we want. So just place it over there, or you can manually write it so that you don't want to take any chances for any more risks. So order ID, there you go. Just run this query. And now let's select the data from customer ID once again. And there you go. You have a proper functional working ID. Now let's rename the order ID column from dealership data as well. So I want to rename customer data to dealership data. Just copy the name of the table and replace it over here. And yeah, let's check the columns first. There you go. You have a similar problem here. So let's change our R to the name of the first column in dealership data as well. Now quickly run the query, and now let's select the data from the dealership data. There you go. So we have a fully functioning or fully corrected data set. So we have order data. Remember, you can see I'm using underscore symbol here whenever or wherever I feel like having the space. You can eliminate the space and keep it as order ID in a continuous form without having a space or without having a underscore. But remember, don't just leave it as a simple space. If you leave it as a space, then you might be having deep trouble while you are writing a query to fetch some data. Okay, so SQL or MySQL Workbench might be confused to have spaces in between the column names or the entity names. Let's not make that happen, right? Now let's continue with some queries. So we are currently in the order or dealership data. So here we have some orders data. So we have a product quantity. Now let's build a kind of a problem statement where we have to extract a couple of data sets or a couple of results from the data set that we have. Now let's make use of where statement and try to find some answers, right? Now let's say the dealer wants to know one of the dealership names where it is Prime Auto, right? So he wanted to know how many number of orders Prime Auto dealership has received. Now it's a simple where statement. Let's try to answer the query, answer the solution to the problem. Just write down, select. What do you want to select? I want to select the dealership name, right? Just write down, or let's use the auto suggest mode. So before that, select, leave a space from table name, which is dealership data. Right now you can proceed with the column names. What happens here is when I wrote select from dealership data, it is automatically giving me some recommendations here, right? So the typing time will be less, right? So I want to get back to dealership name, right? Dealership, press tab, and underscore name. I want this dealership name from dealership data, where dealership name is equals to single quote Prime Auto. And I also want to know total number of orders they received. So you can either use count or sum. I'll go with sum of orders. So far so good. So let's run this particular query. Control enter, and there you go. So we have found that Prime Auto dealership has received 5466 number of orders. So if you want to, if you don't want sum of orders here, you can also alias it by typing as total orders received. Yeah. So your column name has been successfully changed, right? And if you don't use alias as, it will still work. There you go. But in case if you want to make the code clearer to your fellow developers, I would recommend to use as, right? Now let's proceed with some other similar where commands so that you have a good habit of how to use where clause in your real-time queries. Now let's go back to our data and see what else we can build as a problem statement. So here we have days to deliver. Now let's say the client wants to know how many cars, if there is a premium, if it's a premium car, then he wants to know the premium cars which took more than 10 days for delivery. Now let's write a where query for that. Place the same query here, and now the name is where auto. I'll use an and statement here. Delivery date or days to deliver is greater than or equal to 10. Or we just copy this and paste it over here. And we don't want the alias. There you go. Now let's run this query. And why don't we also write the product name here, right? So we understand which is that car which is taking so much of time. So some of the cars are BMW X3 Baleno. So maybe some reason why these cars are taking a long time for delivery, right? So what happens here is he's able to understand there are couple of cars from couple of categories or couple of manufacturers which are taking a lot of time for delivering the car. So what he can do is he can write down a request or an email to those manufacturers to reduce the time they are taking to manufacture the product so that he can give an early delivery to his clients, right? Now let's run our query back again to see some more places where we can use the where clause. Right, now let's see, we want to categorize or we want to find out specific cars from the segment sedan or the category sedan where the dealership is Elite Automobiles and the fuel type is diesel, right? Let's try to build a where command for that. Let's copy the same where clause here, paste it again here, product, dealership name, and instead of days to deliver, let's type a category. Instead of prime auto, we will be using Elite Automobiles. And the category is equals to, since we're using character data type, we will be using single quotes or double quotes. Sedan. Control Enter, and there you go. So Elite Automobiles is selecting or he is selling all the sedan class BMW series, and these are the details, right? So if the dealership wanted to know what are the cars or what are the products this particular dealership is selling in category sedan, he wants to know if he's focusing on any other manufacturer or a specific manufacturer, so that he wants to make sure that these type of cars or these type of makers should be proceeding with giving more deliveries of that particular category. Now this is one way of doing it, and now let's identify, since we have a couple of and a few more other categories, we want to find out the total number of orders received based on the category. Let's say the business owner wants to understand which type of category vehicles are being sold a lot, and he wants to make sure that his inventory has good number of such type of vehicles for future deliveries or future orders from the customers. In such situations, you want to group by the category, and group by is also a keyword in MySQL where you can use that and categorize based on the category provided. Okay, let's build the query so that you can understand it in a better way. So let's copy paste the same query here, and now we will change a few terms here. Instead of product, we will write category, and instead of dealership name, and instead of category here again, okay, we will write down sum of orders from dealership data, group by category, and order by sum of orders descending. Now, what does this query mean? It means I want to find out the category. So SUV category, sedan class category, and hatchback category, right? So I want to find out which type of category is getting the highest number of orders, right? In that case, what happens is, if you find out that SUV category is getting a lot of sales, then what you will do, you will buy a lot of SUV based vehicles from the manufacturers and keep them in your inventory, so that whenever you receive an order for that particular vehicle, you can show the options and make a sale, right? And why are we using order by, right? So we want to find out the highest number of sales, right? Order by descending, what it does is it keeps the highest selling category on top and the lowest selling category on the bottom. So if I run this query, you will understand what exactly I meant. So here you can see SUV category is the one which is receiving the highest number of orders, followed by hatchback, sedan, and multi-purpose vehicle, MPV, right? Now these are the vehicles. So what you will do is, the next business decision what you make is, you will try to order a couple of more SUVs for your inventory, and it can be from different manufacturers, and then you will provide multiple options when a candidate or when a client comes for buying SUV type vehicles. Now, to deep dive, let's say, since you've already found out SUV is highest selling, and now you want to find out which is that one single car in SUV category which is getting those many high orders, right? So that you want to make sure that you want to understand this particular car is getting highest number of sales from SUV. So I want to keep a little bigger number of that particular car, so that whenever a client comes for that car, I have it ready, right? So if you make slight modifications to this query, you can come up with that category, and I'll also include product and sum of orders, and order by product, group by product, order by sum of orders descending. Now I am expecting a small error here, but it's all right. There you go. So we might have to place category as well. Okay. Let's try to run this query once again. There you go. So now we also might have to use a where command here, where category is equals to SUV. Now run the query. I guess you will find the answer. There you go. So BMW X3 series is that one SUV which is getting a lot of orders, right? Now if you scroll down, yeah, these are the top five SUV products for which we are receiving total number of highest orders. So what we did here is, we are selecting the category column, product column, and total number of orders, right? So we are filtering, basically we are using where command to filter down the data. So wherever the category is equals to SUV, filter those data alone. And now we are grouping by the product, which is here, group by product and category, and order by sum of orders descending. Keep the highest orders on top and the lowest orders on the bottom section where the category is SUV. So in categories SUV, the lowest orders received are 1130 for BMW X5 series. So what you can do is, if you want to cut down, if your inventory is already having a couple of BMW X5 series cars, then what you can do is, you can cut down the imports for that category. And if you have less number of X3 series, you can increase a couple of more cars, maybe 5 to 10 more cars, so that you have your inventory ready with X3 series for your clients, right? So this is how you can use where group by order by in your query. So let's say you wanted to eliminate that particular one product manufacturer which is receiving less number of orders in sedan class. So ASC ascending order, and it is sedan. Now if you run the query, you will find out sedan class BMW X3 is the one which is receiving less number of orders in the category sedan, and you can eliminate that. And if you want to specifically identify a particular dealership name which is having lowest sales, then you can also do that, where category is equals to sedan and dealership name underscore name is equals to Elite Motors, Elite Automobiles. You can also include the dealership name in the column here and group by category and the dealership name. Sum of orders sum of orders ascending, and run this query. And there is some problem here in the query. Dealership name category, error unknown dealership name in the field list. Okay, so Elite Automobiles. Let's copy this from here. So we might have made a spelling mistake in our query, but not a problem. Just place it here, and there you go. Now we must be getting the answer. Okay, dealership name. Okay, we messed out with the dealership name, so we had a spelling mistake in case of dealership name. Yeah, that's the one. And now let's run the query. There you go. So in Elite Automobiles and Sedan class, we have BMW 5 Series in less number of orders received, right? Now, there might be some reason for it. Maybe the location of the dealership, where it is. So there might be chances, right? So where, let's say you are in South India, or let's say you're in North India, or some part of a country where the roads are really wonderful. You don't have a ghat section. You're not living in Western Ghats, and you're having good longer highways. In those segments of roads, you would prefer sedans. But in case if you are in a ghat section, or if you are in a where we have a lot of mountains, a lot of off-roading trekking kind of regions, in those regions you might prefer SUVs, correct? So there is a chance. Now Elite Motors might be in a place where there are some odd roads, not good roads. They might be a hilly region. It might be a region where you don't have good roads, right? Even if you're not in the Western Ghats or a Ghat region, or even if you're not in a region where you don't have any kind of hillies or mountain regions, but the roads are not good, or if you are passionate about it, it might be a trend, right? It might be some cult. If you are coming from a region where there's a good cult for SUVs, right? There might be multiple reasons. So I think that is one of the reasons why there could be a high demand for SUVs or sedans or a specific category of vehicles in a certain region. Now, let's proceed with the next remaining queries or clauses. So far, we have dealt with the with clause, the where clause, and order by, group by clauses. Now, let's proceed with case clause, right? Now, case is something like a switch case where you have, if you're familiar with the switch cases in programming, then case is similar to that in SQL. Now, let's say the dealer wants to identify, or the business owner wants to identify different dealership names based on the profit they make, right? Or the number of the revenue they make. Then he wants to find out the highest profit making category as high profit, the medium profit, and the low profit. So the threshold is like 1 million. If they're making 1 million, then they are under highest category. If they are making in between 50 to 1 million, they're medium. And if they're making lower than that, then they are least profiting. And if they are least profiting, they might have to, the business owner might have to take some decisions, might be like helping them improve their sales, or fixing their contracts, or if they want to collaborate or combine that particular dealership, the high performing one, right? Some business decisions to make sure that everyone is breaking even in their profits. Now let's use the switch statement here. So as I discussed, high profit. So I am going to take two columns here. So selecting the dealership name, sum of profit they are making, and case starts here. When sum of profit, I'm calculating the profit here, revenue minus the cost to company, is greater than 1 million rupees, that is 10 lakh rupees, then it is considered as high profit. And if the profit is between 50,000 or 5 lakhs or 1 million, then it is moderate profit, else low profit. Now, let's run this query, and we're grouping them by dealership. Let's run this query and see the output. There you go. So we have profit categories. Here we have high profit result. Okay, let's minimize this section here. Yeah, there you go. So there are 5 to 6 dealerships we have across the country, and most of them are in high profit, or all of them are in high profit. So if we increase the number to 10 million, so far we had 1 million, so if it is between 5 million to 10 million, now let's run the query and see if we have any. Yeah, so most of them are making good profits here. There you go. So far so good. Now this is how you can use a switch case statement. Now let's say I also want, okay, let's first use the pattern matching case here, kind of like statement we can use here, like clause. Now I want to make sure to identify a specific product. Okay, let's run this query once again, where we have the dealership data, select all from dealership data. So now we have 8 series, X8 series, right? So some of the premium vehicles. Now I'd like to go with X8, BMW X8. So I want to identify the dealership names which are selling X8 series. Now we can write down the query as select dealership name. What you can do is just copy the dealership name so that we don't make any spelling mistakes. I think we wrote dealership. Yeah, we can remove this. Dealership name product from dealership data, where product like, or you can use like, I think we don't need to use equals to there, double quotes, mod, percentage or mod, X8 and percentage. Okay, so what am I specifically mentioning here is, I don't care if it is having anything in front of X8 and after X8. So we are damn sure that the series X8 will be released only by BMW. So in few scenarios, the BMW could be in small cases, or there might be no space in between BMW and X8, right? So I don't want to take a chance. So I want the exact details. So I don't care if there is a space or not, if there is anything else. There might be even spelling mistakes, BM or Beamer X8, or the full form of BMW, right? So, and after X8, I don't want to take any chances here as well. It might be series, it might be cars, right? So I want every detail, the dealership name and the product from the dealership data, who is having X8 car in their inventory. There you go. So we have so many dealerships here. So if I have to take the exact names, or if I don't want any repetitions, then I can go with the distinct here. So distinct of dealership names, where we can find out who is dealing with X8 in their inventory. So we have 5 automakers here, 5 dealerships who are having X8 in their inventory. Now let's also have a count, right? So we can make sure that how many number of X8s they have, count of product. So we can understand how many number of, okay, so there is some query mistake here, aggregated without group by. So here we can add another statement, a group by dealership name or distinctive dealership name. I'll just go with dealership name here, and order by count of product is sending. Now let's try to run this query by product. Now let's run the query. There you go. So we have City Motors, who has the highest count of BMW X8 series, and they have the biggest inventory, I presume. So in the next upcoming fiscal year, if there is a requirement of importing X8, then you can check out the numbers, right? If you want to import a huge inventory, or if you want to reduce the number. And you can also, if there is a good sale for Asian dealership for BMW X8 series, you can also improvise their numbers as well. So that's how you can use the pattern matching statement. And if you don't want, if you want to exclude X8, then what you can do is just place an I here, I like, or product not like X8. So if you're filtering out X8 and running numbers or codes for everything every other car but X8. You just want to run that query, and here you can see instead of X8 you can have details repeat, and you can see instead of X8 you have every other detail on every other car. That's how you can go with it. Now let's proceed with the joins in our tutorial for today. Now let's create a use case, right? You wanted to identify all the customers who bought an X8, right? So if you check the data, if we go back to our query here and run the dealership query, and you can see here we have order ID, order date, delivery date, everything, but we don't have customer name. But I want the customer name, but customer name is in the table customer data, right? And here we don't have the product detail what they bought, right? So Vivan, Sai or Vihan are it can be anyone who got an X5 or X8, right? But now I want to know the exact customers who are or who have already placed an order for X8, or you've already delivered that X8, right? Or let's say you wanted to know if they have placed an order for X8. Now in this situation you might want to make use of joins which join two tables and give you the results. So there are basically a couple of joins that you can use: left join, right join, inner join, outer join, Cartesian join, right? So most of the cases you would just go with the keyword join. So it will basically function like a left join, right? You're choosing the first table and you are choosing the matching data from the right table. Now we want the order ID column, we want the customer name, and also the product name, which is equals to X8, and we want to run a join command based on order ID. So order ID happens to be the primary key based on which you can perform the join. So it could be a little complicated orally, so I will write the query so that you have a better understanding for it. So let's quickly run the query. I'm going to use the select statement here, and we wanted the customer name, right? So we want the customer name, or we have it here, right? Double click, copy the field name so that we don't have any mistakes done, and it is from customer data, right? So customer data dot customer name. Okay, let's also copy the customer data table name as well, right? So that we don't have any mistakes in our query. And want dealership data table name as well, so comma dealership data, and what we want from dealership data is product, and we also want dealership data dot order ID, copy the field name, comma from dealership data join customer data to dealership data on what terms. So order ID is common between customer data and order data, right? So we want order ID equals to order ID, but it will be confusing. So what we can do is join customer data on customer data dot order ID and dealership data dot order ID, right? And we will also use a where clause where product dealership dot product, like again the same statement which is here. There you go. Now we are selecting order ID from dealership data, customer name from customer data, and product name from dealership data from the table dealership data. Join customer data table on customer data dot ID is equals to dealership data dot ID, which is the order ID, where dealership data dot product, right? The product details are in dealership data table, and the product is like anything before X8, anything after X8, because we want the details only for X8, the customers who bought X8. Right, now let's run this query, and there you go. So these are the customers who bought X8s. So we have about 29 results. 29 members are the premium customers who got this premium vehicle X8 series. Now that's how you can use joins in a SQL table, a SQL data query. And so far we have covered joins, we have covered case, we have covered pattern matching, we have covered where clause, group by, order by, and select, and few others. So we have also made a complete documentation out of it. We now know how to create a schema, how to import data, and few protocols to follow when you're importing data, like using an underscore. And we also have covered alter table if you have some mistakes in your column name, how to alter the name of that column, right? So these are the fundamentals that you can know about SQL, and also some advanced concepts like case and joins that you can know about SQL. So far we have covered everything that you must know for a beginner, and also we have covered something if you're an advanced level SQL developer. It's like a brushing up tutorial for you, how to use some clauses like group by, order by, and how to use cases, how to use joins, right?
So let's understand what an ER diagram is. An entity relationship diagram describes the relationship of entities that needs to be stored in a database. ER diagram is mainly a structural design for the database. It is a framework made using specialized symbols to define the relationship between entities. ER diagrams are created based on the three main components: entities, attributes, and relationships. Let's understand the use of ER diagram with the help of a real-world example. Here, a school needs all its student records to be stored digitally, so they approach an IT company to do so. A person from the company will meet the school authorities, note all their requirements, describe them in the form of ER diagram, and get it cross-checked by the school authorities. As the school authorities approve the ER diagram, the database engineers would carry further implementation. Let's have a view of an ER diagram. The following diagram showcases two entities, student and course, and the relationship. The relationship described between student and course is many-to-many, as a course can be opted by several students, and a student can opt for more than one course. Here, student is the entity and it possesses the attributes, that is, student ID, student name, and student age. And the course entity has attributes such as course ID and course name. Now we have an understanding of ER diagram. Let us see why it has been so popular. The logical structure of the database provided by ER diagram communicates the landscape of business to different teams in the company, which is eventually needed to support the business. ER diagram is a GUI representation of the logical structure of a database, which gives a better understanding of the information to be stored in a database. Database designers can use ER diagrams as a blueprint, which reduces complexity and helps them save time to build databases quickly. ER diagrams helps you identify the entities that exist in a system and the relationships between those entities. After knowing its uses, now we should get familiar with the symbols used in ER diagram. The rectangle symbol represents the entities, oval symbol represents attributes, a rectangle embedded in a rectangle represents a weak entity, a dashed oval represents a derived attribute, a diamond symbol represents a relationship among entities, double oval symbol represents multi-valued attributes. Now we should dive in and learn about the components of ER diagram. There are three main components of ER diagram: entity, attribute, and relationship. Entities have weak entity. Attributes are further classified into key attribute, composite attribute, multi-valued attribute, and derived attribute. Relationships are also classified into one-to-one relationships, one-to-many relationships, many-to-one relationships, and many-to-many relationships. Let's understand these components of ER diagram, starting with entities. An entity can be either a living or a non-living component. An entity is showcased as a rectangle in an ER diagram. Let's understand this with the help of an ER diagram. Here, both student and course are in rectangular shape and are called entities, and they represent their relationship study in a diamond shape. Let's transition to weak entity. An entity that makes reliance over another entity is called a weak entity. The weak entity is showcased as a double rectangle in ER diagram. In the example below, the school is a strong entity because it has a primary key attribute, school number. Unlike the school, the classroom is a weak entity because does not have any primary key, and the room number attribute here acts only as a discriminator and not a primary key. Now, let us know about attributes. Attribute. An attribute exhibits the properties of an entity. An attribute is illustrated with an oval shape in an ER diagram. In the example below, student is an entity and the properties of student such as address, age, name, and roll number are called its attributes. Let's see our first classification under attribute, that is key attribute. The key attribute uniquely identifies an entity from an entity set. The text of a key attribute is underlined. In the example below, we have a student entity and it has attributes name, address, roll number, and age. But here, roll number can uniquely identify a student from a set of students. That's why it is termed as a key attribute. Now, we will see composite attribute. An attribute that is composed of several other attributes is known as a composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected with other ovals. In the example below, we can see an attribute name, which can have further subparts such as first name, middle name, and last name. These attributes with further classification is known as composite attribute. Now, let's have a look at multi-valued attribute. An attribute that can possess more than one value are called multi-valued attributes. These are represented as double oval shape. In the example below, the student entity has attributes phone number, roll number, name, and age. Out of these attributes, phone number can have more than one entry, and the attribute with more than one value is called multi-valued attribute. Let's see derived attribute. An attribute that can be derived from other attributes of the entity is known as a derived attribute. In the ER diagram, the derived attribute is represented by dashed oval, and in the example below, student entity has both date of birth and age as attributes. Here, age is a derived attribute as it can be derived by subtracting current date from the student date of birth. Now, after knowing attributes, let's understand relationship in ER diagram. A relationship is showcased by the diamond shape in the ER diagram. It depicts the relationship between two entities. In the below example, student, study, course. Here, both student and course are entities and study is the relationship between them. Now, let's go through the type of relationship. First is one-to-one relationship. When a single element of an entity is associated with a single element of another entity, this is called one-to-one relationship. In the example below, we have student and identification card as entities. We can see a student has only one identification card and an identification card is given to one student. It represents a one-to-one relationship. Let's see the second one, one-to-many relationship. When a single element of an entity is associated with more than one element of another entity is called one-to-many relationship. In the below example, a customer can place many orders, but a particular order cannot be placed by many customers. Now, we will have a look at many-to-one relationship. When more than one element of an entity is related to a single element of another entity, it is called many-to-one relationship. For example, students have to opt for a single course, but a course can be opted by a number of students. Let's see many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity is called many-to-many relationship. For example, an employee can be assigned to many projects, and many employees can be assigned to a particular project. Now, after having an understanding of ER diagram, let us know the points to keep in mind while creating the ER diagram. First, identify all the entities in the system, embed all the entities in a rectangular shape and label them appropriately. This could be a customer, a manager, an order, an invoice, a schedule, etc. Identify relationships between entities and connect them using a diamond in the middle illustrating the relationship. Do not connect relationships. Connect attributes with entities and label them appropriately, and the attributes should be in oval shape. Assure that each entity only appears a single time, and eradicate any redundant entities or relationships in the ER diagram. Make sure your ER diagram supports all the data provided to design the database. Make effective use of colors to highlight key areas in your diagrams.
There are mainly 4 types of SQL commands. So first we have Data Definition Language or DDL. So DDL commands change the structure of the table, like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have Data Manipulation Language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete, and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first, we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2, and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2, and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit, and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp, and others. Then we have string data type, which includes char, this varchar, and text. Finally, we have binary data types, and binary data types have binary, var binary, and image. Now let's see some of the various operators that are present in SQL. So first we have our basic arithmetic operators. So you have addition, the subtraction, multiplication, division, and modulus. Then we have some logical operators like all, and, any, or, between, exists, and so on. Finally, we have some comparison operators such as equal to, not equal to, this greater than, less than, greater than equal to, or less than equal to, not less than, or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types, and operators that we just learned.
In this session, we will learn how to install MySQL Workbench and then we will run some commands. Firstly, we will visit the official Oracle website, that is mysql.com, and now we will move to the downloads page. Now scroll down and click on MySQL GPL downloads. Now under community downloads, click on MySQL installer for Windows. The current versions are available to download. I will choose this installer and click the download button. Now here just click on no thanks, just start my download. Once the installer has downloaded, open it. You may be prompted for permission. Click yes. This opens the installer. You will be asked to choose the setup type. We will go with custom. Click next. Now you have to select the products you want to install. We will install only the MySQL Server, MySQL Shell, and the MySQL Workbench. Expand MySQL Servers by double clicking on it. And choose the version you want to install and click on this arrow. Now you have to do the same thing for applications. Expand applications and choose the MySQL Workbench version you want to install and click on the arrow. And we'll do the same thing for MySQL Shell. We'll choose the latest version, click on the arrow. So these are the products that have to be installed in a system. Now we'll click next. I'll click execute to download and install the server. This may take a while depending on your internet speed. As the download is completed, click next. Now you'll see the product configuration. Click next. Now we'll configure our SQL Server instance. Here we'll go with the default settings and click next. And under authentication, select use strong password encryption for authentication, which is recommended, and click on next. Now here set the password for your root user. By the way, root is the default user. This user will have access to everything. I will set my password. Now I'll click on next. And here also we'll keep the default settings and click on next. Now to apply configuration, we will execute the process. Once all the configuration steps are complete, click finish. Now you will see the installation is complete. It will launch MySQL Workbench and MySQL Shell after clicking on finish. Now the shell and workbench has started. Now we'll connect by clicking on the root user. It will ask for a password. Enter the password and it will connect successfully. The workbench has started. Now we'll just connect the server. So first we'll open command prompt. Now we'll reach the path where MySQL files are present. We'll go into this PC, local disk C, program files, MySQL Server 8.0 bin, and now we'll copy this path. Now we'll open the command prompt and write a command cd space and paste the link and press enter. Now we'll write another command that will be MySQL -u space root -p and press enter. Now it will ask for your password. Just enter the password and press enter. Now the server has started and now we'll see some commands in MySQL Workbench. First we will open MySQL Workbench. Now we'll click on the local instance MySQL AT and enter the password to connect to the local host. The MySQL Workbench has started. Now we will see some commands. The first command we will see is show databases. Show databases semicolon, and now we will select the whole command and click on this execute button, and here we will see the result in the result grid. These are the databases that are stored already in the database. Now there are 4 databases, that is Information Schema, MySQL, Performance Schema and SYS. Now we will select one of the database. We will use MySQL. Now we have selected the MySQL database, and now in this database we will see which tables are stored in this MySQL database. To see that, we will run a command show tables. We'll select the command and click on the execute button. These are the tables that are stored in this MySQL database, that is columns, underscore prive, component, DB and much more.
Now let me now go ahead and open my MySQL workbench. So in the search bar I'll search for MySQL workbench. You can see I'm using the 8.0 version. I'll click on it and here it says welcome to MySQL workbench, and below under connections you can see I have already created a connection which says local instance. Then you have the root, the local host and the port number. Let me click on it. You can see the service, the username is root, and I'll enter my password and hit OK. Now this will open the SQL editor. So this is how the MySQL workbench looks like. Here we learn some of the basic SQL commands. So first let me show you the databases that are already present. So the command is show databases. You can hit tab to autocomplete. I'll use a semicolon. I'll select this, and here on the top you can see the execute button. So if I run this, below you can see the output. It says show databases, 7 rows are returned, which means currently there are 7 databases. You can see the names. Alright, now let's say I want to see the tables that are present inside this database called world. So I'll use the command use world, which is the database name. Now let me run it. So currently I'm using the world database. So to display the tables that are present in the world database, I can use the show command and write show tables. Give a semicolon and I'll hit Control Enter this time to run it. Alright, so you can see the tables that are present inside this world database. So we have 3 tables in total: city, country and country language. Now if you are to see the rows that are present in one of the tables, you can use the select command. So I'll write select star, which basically means I want to display all the columns. So star here means to display all the columns. Then I'll write my from the table name, that is city. So this command is going to display me all the rows that are present inside the city table. So if I hit Control Enter, alright, you can see the message here. It says 1000 rows were returned, which means there were total 1000 records present inside the city table. So here you can see there's an ID column, a name column, this country code, district and population. Alright. Similarly, you can check the structure of the table by using the describe command. So I'll write describe and then I'll give the table name, that is city. Now let's just run it. There you go. The field shows the column names. So we have ID, name, country code, district, population. Type here shows the data type of each of the columns. So district is character 20, ID is an integer, population is also integer. Null says yes or no, which means if no, then there are no null values. If it's yes, which means there are null values in your table. Key here represents whether you have any primary key or foreign key, and these are some extra information. Now let's learn how to create a table in MySQL. So I'll use the create table command for this, and before that let me create a database and I'll name it as SQL Intro. So the command is create database and I'll give my database name, that is SQL_intro. Let me give a semicolon and hit Control Enter. So you can see I have created a new database. Now if I run this command, that is show databases, you can see this newly created database, that is SQL Intro. If I scroll down, there you go, you can see the name here, SQL Intro. Okay, now within this database we'll create a table called employee details. Now this will have the details of some employees. So let me first show you how to create a table that will be present inside the SQL Intro database. So I'll use the command create table, and then I'll give my table name that is going to be employee underscore details. Next, the syntax is to give the column names. So my first column would be the name column, which is basically the employee name, followed by the data type for this column. Since name is a text column, so I'll use varchar and I'll give a value of 25. So it can hold only 25 characters. Okay. Next, I also want the age of the employee. Now age is always an integer, so I'll give int. Okay. Then we can have the gender of the employee. So gender can be represented as F or M, F for female and M for male. So I'm using the char data type or character data type, and I'll give the value as 1. Then let's have the date of join or DOJ, and this is going to be of data type date. Alright. Next, we'll have the city name, that is the city to which the employee belongs to. So again, this is going to be varchar 15. Finally, we'll have a salary column, and salary we'll keep it as float, since salary can be in decimal numbers as well. Now I'll give a semicolon. Alright, so let me just quickly run through it. So first I wrote my create command, then the table, which is also a keyword, followed by the table name, which is employee details here, and then we gave the column names such as name, age, this gender, date of join, city and salary. For each of the columns we also give the data type. Alright, so let me just run it. Okay, so here you can see we have successfully created our first table. Now you can use the describe command to see the structure of the table. I'll write describe emp underscore details. If I run this, there you go. So under field you can see the column names, then you have the data types. Null represents if the table can accept null values or not, and these are basically empty, and we haven't set any default constraint. Alright, moving ahead. Now let's learn to add data to our table using the insert command. So on a notepad I have already written my insert statement, so let me just copy it and then I'll explain it one by one. Alright, so if you see this, so we have used an insert into statement or a command followed by the table name, that is emp details. Then this is the syntax. Using values I have passed in all the records. So first we have Jimmy, which is the name of the employee, then we have 35, which basically represents the age, then M means the gender or the sex, then we have the date of join, next we have the city to which the employee belongs to, and finally we have the salary of the employee. So this particular information represents one record or a tuple. Similarly, the next employee we have is Shane. You can see the age and other information. Then we have Mary, this Dwayne, Sarah and Amy. Alright, so let me go ahead and run this. So this will help you insert the values in the table that you have created. You can see we have successfully inserted 6 records. Now to display the records, let me use the select statement. So I'm using select star from emp underscore details. If I run this, you can see my table here and the values it has. So we have the name column, the age column, the state of join, city, salary, and these are the values that you can see here. Moving ahead, now let's say you want to see the unique city names present in the table. So in this case you can use the distinct keyword along with the column name in the select statement. So let me show you how you can print the distinct city names that are present in our table. Now if you notice this table clearly, we have Chicago, Seattle, Boston, Austin, there's New York, and there's Seattle repeated again. So I only want to print the unique values. So for that, I can write my select statement as select distinct. Then I'll give my column name, which is city, from my table name, that is EMP details. If I run this, you can see my query has returned 5 rows and these are the values. So we have Chicago, Seattle, which was repeated twice, is just been shown once. Then we have Boston, Austin, and New York. Now let's see how you can use inbuilt aggregate functions in SQL. So suppose you want to count the number of employees in the table. In that case, you can use the count function in the select statement. So let me show you how to do that. So I'll write select. I'll use my function name, that is count. Now since I want to know the total number of employees, I'm going to use their name inside the brackets from employee underscore details. Now if I run this, this will return the total number of employees that are present in the table. So we have 6 employees in total. Now if you see here in the result, it says count name. Now this column is actually not readable at all. So what SQL provides is something called as an alias name. So you can give an alias to the resultant output. So here I can write select count of name and use an alias as I can give an alias as count underscore name and run this statement again. There you go. You can see here in the resultant output we have the column name as count name, which was our alias name. Now suppose you want to get the total sum of salaries, you can use another aggregate function called sum. So I'll write my select statement, and this time instead of count I'm going to write sum, and since I want to find the sum of salaries, so inside the bracket I'll give my salary column from my table name, that is employee details. If I run this, this will result in the total sum of salaries. So basically it adds up all the salaries that were present in the salary column. Now let's say you want to find the average salary. So instead of sum, you can write the average function, which is avg. So this will give you the average salary from the column salary. So you can see it here. This says average salary. Now if you want, you can give an alias name to this as well. Now you can select specific columns from the table by using the column names in the select statement. So initially we were selecting all the columns. For example, like you saw here, the star represents that we want to see all the columns from the employee details table. Now suppose you want to see only specific columns, you can mention those column names in the select statement. So let's say I want to select just the name, age, and the city column from my table, that is employee details. So this will result in displaying only the name, age, and city column from the table. If I run it, there you go. It has given only 3 columns to me. Now SQL has a where clause to filter rows based on a particular condition. So if you want to filter your table based on specific conditions, you can use where clause. Now where clause comes after you give your table name. So suppose you want to find the employees with age greater than 30. In this case, you can use a where clause. So let me show you how to do it. I'll write select star from my table name, that is employee details, and after this I'll use my where clause. So I'll write where age greater than 30. If I run this, it will give me the output where the age is only greater than 30. So it excluded everything that is less than 30. So we have 4 employees whose age is greater than 30 here. Now suppose you want to find only female employees from the table, you can also use a where clause here. So I'll write select, let's say I want only the name, the gender which is sex here, comma city from my table that is employee details, where I'll give my column name that is sex is equal to, since I want only the female employees, I'll give F and run this statement. Okay, you can see here our employee table has 3 female employees. Now suppose you want to find the details of the employees who belong to Chicago or Austin. In this case, you can use the OR operator. Now the OR operator in SQL displays a record if any of the conditions separated by OR is true. So let me show you what I mean. So since I want the employees who are from Chicago and Austin, I can use an OR operator. So I'll write select star from emp details, which is my table name. Then I'll give my where clause where city equal to, I'll give my city name as Chicago, and then I'm going to use the OR operator, or city equal to, I'll write Austin. I'll give a semicolon and let me run it. There you go. So in the output you can see all the employees who belong to the cities Chicago and Austin. Now there is another way to write the same SQL query. So you can use an in operator to specify multiple conditions. So let me just copy this, and instead of using the OR operator, this time I'm going to use the in operator. So I'll delete this. After the where clause, I'm going to write where city and use the in operator. Inside bracket, I'll give my city names as Chicago and I want Austin. So I'll give a comma and write my next city name, that is Austin. So this query is exactly the same that we wrote on top. Let me run this. You will get the same output. There you go. So we have Jimmy and Dwayne who are from Chicago and Austin respectively. Now SQL provides the between operator that selects values within a given range. The values can be numbers, text or dates. Now suppose you want to find the employees whose date of join was between 1st of Jan 2000 and 31st of December 2010. So let me show you how to do it. I'll write select star from emp details where my date of join, that is DOJ, between, I'll give my two date values, that is 1st of Jan 2000 and I'll give my second value, the date value, that is 31st of December 2010. So every employee who has joined between these two dates will be displayed in the output. If I run it, we have two employees who had joined between 2000 and 2010. So we have Jimmy and Mary here who had joined in 2005 and 2009 respectively. Alright. Now in where clause, you can use the AND operator to specify multiple conditions. Now the AND operator displays a record if all the conditions separated by AND are true. So let me show you an example. I'll write select star from employee details table where I want the age to be greater than 30 and I want sex to be male. Alright, so here you can see I have specified two conditions. So if both the conditions are true, only then it will result in an output. If I run it, you can see there are two employees who are male and their age is greater than 30. Now let's talk about the group by statement in SQL. So the group by statement groups rows that have the same values into summary rows. Like for example, you want to find the average salary of customers in each department. Now the group by statement is often used with aggregate functions such as count, sum and average to group the result set into one or more columns. Let's say we want to find the total salary of employees based on their gender. So in this case you can use the group by clause. So I'll write select, let's say sex, comma, I want to find the total sum of salary, as I'll give an alias name, let's say total salary, from my table name, that is employee details. Next I'm going to group it by sex. Okay, let me run it. There you go. So we have two genders, male and female, and here you can see the total salary. So what this SQL statement did was, first it grouped all the employees based on the gender, and then it found the total salary. Now SQL provides the order by keyword to sort the result set in ascending or descending order. Now the order by keyword sorts the records in ascending order by default. To sort the records in descending order, you can use the DESC keyword. So let's say I want to sort my employee details table in terms of salary. So I'll write select star from emp underscore details, and I'll use my order by clause on the salary column. So this will sort all the records in ascending order of their salary, which is by default. You can see the salary column is sorted in ascending order. Now suppose you want to sort the salary column and display it in descending order, you can use this keyword, that is DESC. Let me run it. You can see the output. Now this time the salary is sorted in descending order, and you have the other values as well. Now let me show you some basic operations that you can do using the select statement. So suppose I write select and do an addition operation, let's say 10 plus 20, and I'll give an alias name as addition. If I run this, it will give me the sum of 10 and 20, that is 30. Similarly, you can use the subtraction operator, and you can change the alias name as, let's say, subtract. Let's run it. You get minus 10. Now there are some basic inbuilt functions. There are a lot of inbuilt functions in SQL, but here I'll show you a few. Suppose you want to find the length of a text or a string, you can use the length function. So I'll write select and then use the length function. I'll hit tab to autocomplete. Let's say I want to find the length of country India, and I'll give an alias as total length. If I run it, you see here it returns 5 because there are 5 letters in India. There's another function called repeat. So let me show you how repeat works. So I'll write select repeat. Let's say I want to repeat the symbol, that is at the rate. I'll put it in single quotes because it is a text character, and I want to repeat this character for 10 times. Close the bracket and let's run it. You can see here in the output it has printed at the rate 10 times. You can count it. Alright. Now let's say you want to convert a text or a string to uppercase or lowercase. You can do that as well. So I'll write select and use the function called upper. Let's say I want to convert my string, that is India, to uppercase. I'm not giving in any alias name. If I run this, see, my input was capital I and everything else was in small letter. In the output you can see it is converted my input to all caps. Similarly, you can change this. Let's say you want to print something in lowercase, you can use the lower function. Let's say this time everything is in uppercase. If I run it, it converts India to lowercase. Now let's explore a few date and time functions. Let's say you want to find the current date. There's a function called CUR, which stands for current, and this is the function I'm talking about, which is current date. If I run this, you will get the current date, that is 28th of Jan 2021. And let's say you want to extract the day from a date value, so you can use the day function. Let's say I'll use day, and I want to find the day from my current date. If I run this, you get 28, which is today's day. Now similarly, you can also display the current date and time. So for that, you can use a function that is called now. So this will return the current date and time. You can see this is the date value, and then we have the current time. Alright. And this brings us to the end of our demo session. So let me just scroll through whatever we have learned. So first, I showed you how you can see that databases present in MySQL. Then we used one of the databases and checked the tables in it. Then we created another database called SQL Intro for our demo purpose. We used that database, and then we created this table called employee details with column names like name, integer, the sex, date of join, city, and salary. I showed you the structure of the database. Let me run this again so you get an idea. You can see this was the structure of our table. Then we went ahead and inserted a few records. So we inserted records for 6 employees. So you have the employee name, the age, the gender, the date of join, the city to which the employee belongs to, and the salary of the employee. Then we saw how you can use the select statement and display all the columns present in the table. We learned how you can display the unique city names. We learned how to use different aggregate functions like count, average, and sum. Then we learned how you could display specific columns from the table. We learned how to use where clause. Then we used an or operator. We learned about in operator, the between operator. Then we used an and operator to select multiple conditions. Finally, we learned about group by, order by, and some basic SQL operations. Now it's time to explore some string functions in MySQL. So I have given a comment, string functions. First, let's say you want to convert a certain string into uppercase. So I can write select. The function I'll use is upper, and within this function you can pass in the string. Let's say I'll write India. If you want, you can give an alias name as, let's say, uppercase. I'll give a semicolon and let's run it. There you go. So my input was in sentence case, and using the upper function we have converted everything into uppercase. Similarly, let me just copy this and I'll show you. If you want to convert a string into a lowercase, you can use the lower function. I'll run this. You can see the result. Everything is in lowercase now. Of course, I need to change the alias name to lowercase. Now, instead of using lower as the function, there is another function that MySQL provides, which is called the L case. So I'll just edit this and write L case, and let's say I'll write India in uppercase. Let's run it. It returns me the same result. Cool. Now moving on, let's say you want to find the length of a string. You can use the character length function. I'll write select, use the function character length, and I'm again going to pass in my string as India as, let's say, total length. Let's run it. This time I'm going to hit Control Enter to run my SQL command. There you go. It has given us the right result, which is 5, because India has 5 characters in it. Now these functions you can also apply on a table. Now let me show you how to do it. Let's say we already have the students table and you want to find the length of each of the student names. So here you can pass stu underscore name, and you can give the same alias name, let's say total length, and then you can write from table name, that is students. If I run this, you can see the output. It has given me total 20 rows of information. It is not readable actually. Let me also display the student names so that we can compare their length. Alright, I'll run this again, and now you can see the result. So Joseph has 6 characters, Nilesh has 6, Vipul has 5, Anubhav has 7. Similarly, if you see, Akshay has 6, Tanishq has 7, Raghav has 6, Cummins has 7, Rabada has 6, so on and so forth. Now instead of using this character length, you can also use the function char length. It will work the same way. Let's see the result. There you go. It has given us the same result. You can either use character length or char length. Now there's another very interesting function called concat. So the concat function adds 2 or more expressions together. Let's say I'll write select. I'll use the function concatenate. The function is actually concat, and I'm going to pass in my string values. Let's say India is in Asia. Let's run this and see our result. You can see here it has concatenated everything. Let us make it more readable. I'll give a space in between so that you can read it clearly. Now this is much more readable. India is in Asia, and if you want, you can give an alias name as well, as let's say merged. There you go. Now the same concat operation you can also perform on a table. I'm going to use the same students table. Let's say I want to return the student ID followed by the student name, and then I am going to merge the student name followed by a space followed by the age of the student, and I can give an alias as let's say name underscore age from my table, that is students. Let's see how this works. Okay, you see here the result is very clear. We have the student ID, the student name, and the concatenated column that we created, which was name underscore age, where we have the student name with a space followed by the age of the student. If I scroll down, you can see the rest of the results. Cool. Now moving ahead, let's see how the reverse function works in MySQL. So the MySQL reverse function returns a string with the characters printed in reverse order. So suppose I write select reverse. I'll use the same string again. Let's say I have India. Let's run it. You will see all the characters printed in reverse order. Again, you can perform the same operation on a table as well. Let's say I'll write select reverse, and I'll pass in the column as student name from my table, that is students. Let's run it. It gives you 20 students and all the names have been printed in reverse order. Okay. Now let's see what the replace function does. So the replace function replaces all occurrences of a substring within a string within a new substring. So let me show you what I mean. I'll write select replace. I'll pass in my input string, which is, let's say orange is a vegetable, which is ideally incorrect. I'm purposely writing this so that I can replace the word vegetable with fruit. Okay. So what this replace function does is, it is going to find where my word vegetable is within the string, my input string, and it is going to replace my word vegetable with fruit. Let's run it and see the output. There you go. Now this is correct, which is orange is a fruit. Alright. Now MySQL also provides some trim functions. You can use the left trim, right trim, and just the trim function. So let me show you how this left trim works. Left trim or L trim removes the leading space characters from a string passed as an argument. So say I write select, I'll use the left trim function, which is L trim, and then I'm going to purposely give a few spaces in the beginning of the string. I'll give a word, let's say India, and then I'll give some space after the word India, and see how the L trim works. If I run this, it gives me India, which is fair enough. But before that, let's first find the length of my string. So I'll use my length function here, and within this function I am going to find the length of my string, which has India along with some leading and trailing spaces. I'll paste this here, give a semicolon, and I'll run it. Okay, so the entire string is 17 characters long, or the length of the string is 17. Now say I use ltrim on my same string, what it returns me is India, and if I run length over it, you can see the difference. As in, you can see how many spaces were deleted from the left of the string. You can see here, now it says 17, and I'm going to use ltrim. Let's see the difference. It gives me 12. The reason being, it has deleted 5 spaces from the left. You can count it, 1, 2, 3, 4, and 5. So 17 minus 5 is 12, which is correct. Similarly, you can use the rtrim function, which removes the trailing spaces from a string. Trailing spaces are these spaces. When you use left trim, it deletes the leading spaces, which is this. Now let me just replace ltrim with rtrim, which stands for right trim, and see the result. So the length is 10 now. The reason being, it has deleted 7 spaces from the right of the string. If you can count it, 1, 2, 3, 4, 5, 6, and 7. Cool. You can also use the trim function, which will delete both the leading and the trailing spaces. So here, if I just write trim and I'll run it, it gives me 5, because India is total 5 characters long, and it has deleted all the leading and the trailing spaces. Alright. There's also a function called position in MySQL. The position function returns the position of the first occurrence of a substring in a string. So if the substring is not found with the original string, the function will return 0. So let's say I'll write select position. I want to find where fruit is in my string, that is orange is a fruit. I'll give an alias as name. There's some error here. This should be within double quotes. Now let's run it and see the result. Okay, it says at the 13th place, or at the 13th position, we have the word fruit in our string, which is orange is a fruit. Now the final function we are going to see is called ASCII. So the ASCII function returns the ASCII value for a specific character. Let's say I write select ASCII of the letter small a. If I run this, it will give me the ASCII value, which is 97. Let's say you want to find the ASCII value of 4. Let's see the result. It gives me 52. Alright. In this session, we are going to learn two important SQL statements or clauses that are widely used, that is group by and having. First, we'll understand the basics of group by and having, and then jump into MySQL Workbench to implement these statements. So let's begin. First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no two rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement, and then followed by the column names that we want to select. From, we have the table name, followed by the where condition, and next we have the group by clause, and here we include the column names. Finally, we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company. Then we have the department to which each of these employees belong to. We have the city to which the employees belong to, and then we have the salary in dollars. So actually we'll be using this employees table on MySQL Workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department, and then we are using an aggregate function that is AVG, which is average, and we have chosen the salary column, and here we have given an alias name which is average underscore salary, which appears in the output. You can see here from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL Workbench, where we will implement group by and solve specific problems. Okay, so I am on my MySQL Workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. So this will take us inside this database. I'll run it. Alright, now you can check the tables that are present in SQL underscore intro database. If I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee underscore ID, which is the ID for each employee. I'll give my data type as integer, and I'll assign employee ID as my primary key. Next, I'll give employee underscore name, and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next, we have the date of join, and the data type will be date. We have the department column as well. This is going to be of varchar, and 20 will be the size. Next, we have the city column, which is actually the city to which the employee belongs to. And finally, we have the salary column which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned and here are the department names. So we have sales, marketing, product, tech, IT, finance and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select AVG, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, so the average age of all the employees in our table is 33.35. Now say you want to find the average age of employees in each department. So for this you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says AVG of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also. So you can round the decimal places, so I'll use a round function before the average function, and the round function takes 2 parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright, now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma, now I want the total salary, so I'll use the sum function and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again, and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I'm going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly, we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity. Quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 123, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 121 and let's say 123, since we have just two product IDs here. So for that you can use the select query. So I'll write select product ID. Next, I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally, I'll group it by product ID. Let's run it. There you go. So here you can see we have the two product IDs 121 and 123, and here you can see the revenue that was generated from these two products. Alright. Now let's say we have to find the total profit that was made from both the products 121 and 123. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 121. Let's say the cost price was $270 for each, and next we have my product as 123, and let's say the cost price for product 123 was $250. Let's insert these two values. Okay. Next, we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I am using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by C dot product ID. Let's run this. There you go. So here you can see for product ID 121 we made a profit of $1,100, and for product ID 123 we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees we have grouped it by city, and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function that is average salary. I'll give an alias name as avg underscore salary from employees. Next we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause I'll use my condition that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma, this time since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next, I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT, where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees, where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city, having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees group by department, and in the having clause I'm going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay, so let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. In this session, we will learn about joins in SQL. Joins are really important when you have to deal with data that is present on multiple tables. I'll help you understand the basics of joins and make you learn the different types of joins with hands-on demonstrations on my SQL Workbench. So let's get started with what are joins in SQL. SQL join statement or command is often used to fetch data present in multiple tables. SQL joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL Workbench 8.0 version installed. I'll click on it. So it'll take some time to open. Okay, I'll click on this local instance and here I'll give my password. Okay. So this is how an SQL editor on MySQL Workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Ctrl Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL joins database created. Now I'll use this database, so I'll write use SQL_joins. Okay. Now to understand inner join, consider that there is a college, and in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table, and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar data type and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket_ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First, let's load some data to our cricket table. So I'll write cricket and I'll give my name column followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma. The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay. Now I'll give a semicolon and run this. Okay, so let me just check if all the values were inserted properly. For this I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Aston. I'll just run it. Okay, you can see there are no errors. So we have successfully inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join. My next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So c.name is equal to f.name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select c dot cricket underscore id, comma c dot name, comma f dot football underscore id, comma f dot name. From, I'll write cricket as C, inner join football as F on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay. Now let me just show the different tables that are part of classic tables. Alright. So here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products and product lines as well. Alright. So let me use my select statement to show what are the columns present in the products table. Okay. So this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product. Then we have the quantity in stock, buying price and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright. Now suppose you want to find the product code, the product name and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code. Then we have product name, and let's say I want the text description. So I'll write this column name. Okay. Then I'll use from my first table, that is products, inner join product lines. I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go. So you can see the different product codes. Then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join 3 tables, that is orders, order details and products. So first let me show you what are the columns we have in these three tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed. We also have the shipment date. We also have the status column, which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, you can see it has the order number, the product code, quantity of each product. We have the price of each product. Then we have the order line number. Okay. So using the product, orders and order details, let's perform an inner join. So I'll write select O dot order number, comma, O dot status, comma, I need the product name which I'll take from the products table. So I'll write P dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma, since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue. Then I'll use my from clause, from orders as O, inner join order details as I'll use an alias name as OD, on I'll write O dot order number is equal to OD dot order number. I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as P on P dot product code is equal to OD dot product code. And finally I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here. We need to debug this. It says you have an error in your SQL syntax. Check the manual. Alright. Okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name, and the revenue. This we got it using inner join from 3 different tables. Now talking about left joins, the SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region, and the syntax for SQL left join is something like this. So you have the select statement and then you give the list of columns from table A, which is your left table. Then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write a dot key is equal to b dot key. Okay. Now in our classic models database, we have two tables, customers and orders. So if you want to find the customer name and their order ID, you can use these two tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are two address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing, there are a few rows you can see which have null values. This means for customer number 125 and for this particular customer name there were no orders. And similarly if I scroll down, you will find a few more null values. You can see here there are two null values here. For customer number 168 and 169 there were no orders available. Alright, now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is here I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about right joins. So SQL right join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the right join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose. From table A, right join table B on the common key column from both the tables. Alright. Now to show how right join works, I'll be using two tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name, then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name, we have the extension, the email ID, the job title, and also reports to here means the manager. Okay, so based on these two tables, we'll find the customer name, the phone number of the customer, and the email address of the employee, and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table, so I'll write e dot employee number, comma, e dot email from customers as C, right join employees as E on E dot, my common key column is employee number here, so I'll write E dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see right join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL, known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright, so here you can see we have the employee number, the last name, the first name of the employee, we have the email ID, and here if you see we have a column called reports to. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056, the manager is 1002. So if you check for 1002, we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102, the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188, we have the manager as 1143. Now if I check the table at 1143, we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright, now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join. So let me show you how to join this employees table. I'll write select, and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket, and then I'm going to give my alias name, let's say manager, comma, next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes I'll give my comma, and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot, I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports to column, and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your two columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of two or more select statements. So first of all, let me write C dot customer name. So for this example, I'm using the customer table and the order table, comma O dot order number. So I just want to know the customer name and the order number related to the customer. From, I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join, I'll write right. Rest all looks fine. Let me just run it. There you go. So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright, so that brings us to the end of our demo session. So let me just run through whatever we did in this session. So first we created a database called SQL Joins. Then we created two tables like cricket and football. Then we had inserted a few rows to each of these tables. Then we used this table to learn about inner join. Next we used a database called classic models. It had multiple tables, so we explored all of these tables like products, there was product lines, orders, customers and employees, and learned how to use inner join, left join, self join, right join, as well as full outer join. In this video we will learn what is a subquery and look at the different types of subqueries. Then we learn subqueries with select statement followed by subqueries with insert statement. Moving further, we will learn subqueries with the update statement, and finally we look at subqueries with delete statement. All this we will be doing on our MySQL workbench. So before I begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update. So let's start with what is a subquery. So a subquery is a select query that is enclosed inside another query. So if I show you, this is how the basic structure of a subquery looks like. So here, whatever is present inside the brackets is called as the inner query, and whatever is present outside is called the outer query. So first, the inner query gets executed and the result is returned to the outer query, and then the outer query operation is performed. Alright, now let's see an example. So we have a question at hand, which is to write a SQL query to display department with maximum salary from employees table. So this is how our employees table looks like. It has the employee ID, the employee name, age, gender, we have the date of join, department, city and salary. Now to solve this query, my subquery would look like this. So I'll first select the department from my table, that is employees, where I'll use the condition salary equal to, and then I'll pass in my inner query, which is select max of salary from employees. So what this does is it will first return the maximum salary of the employees in the table. Then our outer query will get executed based on the salary returned from the inner query. So here the output is department sales has the maximum salary. So one of the employees from the sales department earns the highest or the maximum salary. If you see in our table, the employee is Joseph, who earns $115,000. Alright, and Joseph is from the sales department. Now let's see how this query works. So here we have another question, which is to find the name of the employee with maximum salary in the employees table. So this is our previous employees table that we saw, and to find the employee who has the maximum salary, my subquery would look something like this. So I'm selecting the employee name from my table, that is employees, where I'm using the condition salary equal to, and then I'm passing in my subquery or the inner query. So first I'm selecting the maximum salary. This will return a particular value, that is the highest salary from the table. And if you see our table, the highest salary is $115,000. So our query becomes select employee name from employees where salary equal to $115,000. So the employee name is Joseph here, and that's the output. Now if you want to break it down, here you can see first the inner query gets executed. So our SQL query will first execute the inner query that is present inside brackets, select maximum salary from employees. The result is $115,000, and then based on the returned result, our outer query gets executed. So the query becomes select employee name from employees where salary equal to $115,000, and that employee is Joseph. Alright, now we'll learn the different types of subqueries. So you can write subqueries using select statement, update statement, delete and insert statement. We'll explore each of this with the help of example on my MySQL workbench. So let's learn subqueries with the select statement. So subqueries are majorly used with the select statement, and this is how the syntax looks like. You select the column name from the table name, then you have the where condition followed by the columns that you want to pass, the operator, and inside that you have the subquery. So here is an example that we will perform on our MySQL workbench. So in this example, we want to select all the employees who have a salary less than average salary for all the employees. This is the output. So let's do this on my MySQL workbench. Alright, so let me log into my local instance. I'll give my password. Okay, so you can see I'm on my MySQL workbench. So let's start by writing our subquery using the select statement. Okay, so for this demo session, we'll be using a database that is subqueries. You can see it here. I have a database called subqueries. So I'll use this subqueries database and we'll create a few tables as well. Okay, now if I run it, now we are inside the subqueries database. So let me just show you the tables that are present inside this database. I'll write show tables. If I run it, okay, there are two tables, employees and employees underscore B. We'll use this table throughout our demo session. Alright, now for our select subquery, we want to fetch the employee name, the department and the salary whose salary is less than the average salary. So we will be using the employees table. So let me first show you the records and the columns we have in the employees table. So I'll write select star from employees and run it. Okay, you can see here we have 20 rows of information. We have the employee name, the employee ID, age, gender, date of join, department, city and salary. So this is the same table that we saw in our slides. Okay, now for our subquery, I'll write select. I want to choose the employee name, the department and the salary. There should be a comma here instead of a period. Next, I'll give my table name, that is employees, where my salary is less than, and after this I'll start my inner query or the subquery. I'll write select average salary. So I'm using the avg function to find the average salary of all the employees from my table, that is employees. If I give a semicolon and run this, you'll see the output. So we have total 12 employees in the table whose salary is less than the average salary. Now if you want, you can check the average salary. So the average salary is $75,350. Now the employees who have a salary less than the average salary, so these are the people. Alright, now moving back to our slides. Okay, now let's see how you can use subqueries with the insert statement. Now the insert statement uses the data written from the subquery to insert into another table. So this is how the syntax looks like. So you write insert into table name followed by select individual column, so star from the table, use the where clause, and then you give the operator followed by the inner query or the subquery. So here we will explore a table called products table. We are going to fetch few records from the products table based on a condition, that is the selling price of the product should be greater than $100. So only those records will fetch and put it in our orders table. Alright, so we are going to write this query on my MySQL workbench. So let's do it. I'll give my comment as update subquery. Alright, so first of all, let's create a table that is products. So I'll write create table products. Then we'll give our column names. The first column would be the product ID of type integer. Then we have the column as item or the product, which is of type varchar 30. Next we have the selling price of that product. The selling price will be of type float. And finally we have another column which is called the product type. And again, product type is of the data type varchar. I'll give the size as 30, close the bracket and give a semicolon. Now let's just run it. Okay, so we have successfully created our products table. Now let's insert a few records to our products table. So I'll write insert into products followed by values. I'll give 4 records. The first product ID is 101. The product is, let's say, jewelry. Then the selling price is, let's say, $800, and the product type is, it's a luxury product. Next, let's insert one more product detail. The product ID is 102. The product is, let's say, t-shirt. The price is, let's say, $100, and the product type is non-luxury. Next, I'll just copy this to reduce our task. We'll edit this. The third product's ID is 103. The product is laptop, and let's say the price is $1,300, and it's a luxury product. I'll paste again, and finally I'll enter my fourth product, which is, let's say, table, and the price is $400, and it's a non-luxury product. I'll give a semicolon, and we'll insert these 4 records to our products table. You can see we have inserted 4 records. Let's just print it now. So I'll write select star from products. If I run it, you can see we have our 4 products ready. Now we need to create another table where we are going to put some records from our products table. So that new table is going to be the orders table. So I'll write create table orders. Now it will have 3 columns: the order ID. Order ID will be of type integer. Then we have product underscore sold. This will be of type varying character of size 30. And finally we have the selling price column. This will be of type float. Let's create our orders table. The table name should be orders, and there is some mistake here. Okay, you should close the brackets. Okay, let me run it. So we have our orders table ready. Now let's write our insert subquery. So I am going to insert into my table, that is orders, and I'll select the product ID, comma, the item, and the selling price or the sell price from my table, that is products, where I'll write product ID in. I'll write my inner query select prod ID or the product ID from products. Next, I'll give a where clause where the selling price is greater than $1,000. So let me tell you what I am going to do here. I am going to insert into my orders table the product ID, the item name, and the selling price from my products table, where the product ID has this condition. So let me first run this condition for you, which is select prod ID from products where the selling price is greater than 1000. If I run this, okay, there is some issue here. The column name is actually prod ID. Now let's run it again so that we can see the product IDs of the products which have a selling price greater than 1000. So it is 101 and 103. Now let's run the entire query. There is another mistake here. Let's debug the mistake. Now this should be product ID instead of product underscore in. Let's insert again. Alright, so we have successfully inserted 2 records to our table, that is orders. Now let's see the orders table. I'll write select star from orders. If I run it, there you go. So there were two products from our product table that were jewelry and laptop, which have a selling price greater than $1,000. So the selling price for jewelry was $1,800 and for laptop it was $1,300. So this is how you can use a subquery using the insert statement. Alright, now going back to our slides again. Alright, now let's see how you can use subqueries with the update statement. Now the subqueries can be used in conjunction with the update statement. So either single or multiple columns in a table can be updated when using a subquery with the update statement. So this is how the basic syntax of an update subquery looks like. So you write update table followed by the table name, you set the column name, you give the where operator, and then you write your inner subquery. So we are going to see an example where we will use this employees table, and using this employees table we will update the records of the salaries of the employees by multiplying it with a factor of 0.35 only for those employees which have age greater than 27. So we are going to use a new table called employees_b for this as well. So let's see how to do it. So I'll give my comment as update subquery. Before we see the subquery, let's see what we have in the table employees_b. This is basically a replica of the employees table. There you go. It has the same records that our employees table has. We are going to use both the employees table and the employees_b table to update our records. So I'll write update employees set salary equal to, let me bring this to the next line. I'll write set salary equal to salary multiplied by 0.35, where age in, then I'll write select age from my other table, that is employees_b, where age is greater than or equal to, let's say 27. Alright, so let me run through this query and tell you what we are going to do. So I'm going to update the records of the employees table specifically for the salary column. So I'm checking if the age is greater than 27, then we'll multiply the salaries of the employees with a factor of 0.35 in the employees table. Let me just run this, then we'll see our output. Okay, so it says 18 rows affected, which means there are total 18 employees in the table out of the 20 employees whose age is greater than 27. Now if you see, I'll write select star from employees. You can see the difference in the salaries. If I scroll to the right, you can see these are the updated salaries. Okay. Now if you check for employees who have an age less than or equal to 27, for example Marcus, whose age is 25, his salary is the same. We haven't updated his salary. Then if you see, if we have, okay, there is one more employee, Maya. We haven't updated the salary of Maya because the age is less than 27. Alright. Now let's go back to our slides again. As you can see, we got the same output on our MySQL workbench. Now let's explore how you can write subqueries with the delete statement. Now subqueries can again be used in conjunction with the delete statement. So this is how the basic syntax of a delete query using subquery would look like. You write delete from the table name, where clause, the operator value, followed by the inner query in within brackets. So here we are going to use the employees table, and what we are going to do is we'll delete the employees whose age is greater than or equal to 27. So let's see how you can do it. Alright, so I'll give my comment as delete subquery. So we'll follow the syntax that we saw. I'll write delete from my table name, that is employees. I'll write where age in, and then I'll start my inner query or the subquery. I'll write select age from employees underscore B, where age is, let's say, greater than equal to 32, or let's say the age is less than equal to 32. Close the bracket and I'll give my semicolon. Let me first run the inner query for you so that you get an idea of the employees who are less than 32 years of age. So there are 9 employees in the table who have an age less than equal to 32. So we are going to delete the records. If I run this, okay, it says 9 records deleted. Now let's print or display what we have in the employees table. If I run this, there you go. So if you see the age table, we have total 11 employees now, and all their ages are greater than 32 because we have deleted all those employees who had an age less than equal to 32. Okay, so let me show you from the beginning what we did. So first we used our subqueries database, then we used our employees table. So we started by looking at how you can use the subquery with a select statement. This should be insert instead of update. So we learned how to write an insert subquery. We use 2 tables, products and our orders table. Moving ahead, we saw how to write subqueries using the update command. So we updated the salaries of the employee by a factor of 0.35 for those who had an age greater than equal to 27. And finally, we saw how to use the subquery using the delete statement. So we deleted all those records for the employees whose age was less than equal to 32.
So let's start with what is normalization. Normalization in DBMS is a method used to organize data within database to reduce repetition. By breaking down large data sets into smaller, more manageable tables and ensuring these tables are properly related, normalization helps prevent issues like data redundancy. Data redundancy means the unnecessary repetition or duplication of data within a database. For example, when a same piece of data is stored in multiple places, it can lead to inconsistencies and take up more storage space than needed. For example, data redundancy before normalization. You can see the table mentioned above where we have order ID, customer name, customer address, product and quantity. You might see some of the data which is being repeated again and again. In the above table, the customer address for John Doe is repeated 3 times. Let's suppose if John Doe moves to a new address, every occurrence of his address in the table must be updated. If any instance is missed during the update, it leads to inconsistencies and errors can occur in the database. The solution is reducing the redundancy through normalization. Let's check it out how. So you can see this is the normalized table we have created. First is the normalized customer table and then we have the order table. So what are the benefits of normalization? The address for John Doe is stored only once in the customer table. If John Doe's address changes, it needs to be updated in one place, ensuring consistency through the database. This reduces the risk of errors and maintains data integrity. The process involves multiple steps that transform data into a tabular format, removing duplicates and establishing clear connections between different tables, making the database more efficient and reducing problems like errors during data insertion, updates, or deletion. Let's now discuss the types of DBMS normal forms. Normalization rules are categorized into different normal forms. The first one is 1NF. For a table to be in first normal form, it must satisfy the 4 rules. Single valued atomic attributes. Each column should contain only one value per row. This means that there should be no repeating groups or arrays within a single column. Same domain values. All values stored in a specific column should be of the same data type or domain. For example, if a column is meant to store dates, all values in that column should be dates. Then we have unique column names. Each column in the table should have a unique name. This ensures clarity and avoids confusion when referring to a specific column. Then we have order of data, which doesn't matter. The order in which rows are stored in the table should not affect the data or its integrity. Let's check the example of the first normal form. Consider the following unnormalized table: customer ID, customer name, and the phone numbers. As you can see, the phone numbers are repeated twice. The problems with the original table is the non-atomic values. The phone numbers column contain multiple phone numbers separated by commas, which violates the atomicity rule of 1NF. Converting to first normal form, to bring this table into 1NF, we must ensure that each column contains only atomic value. This involves splitting the rows where there are multiple phone numbers. As you can see, we have splitted the data. Each row now has a single phone number, ensuring that the phone number column contains atomic value. Same domain names, all the values in the phone number column are consistent in format and type. All are phone numbers. Then we can see that the unique column names, the columns customer ID, customer name, phone number, which has unique name satisfying the requirement. Order of data, the order in which the rows appear does not matter, as the data's meaning and integrity are preserved. By applying these rules, the table now conforms to the first normal form, eliminating any redundancy related to the phone numbers and ensuring data is stored in a more organized and efficient manner. Let's go through each of these database normal forms step by step with simple examples to help you grasp the concepts more easily. Let's talk about the second normal form. For a table to be in second normal form, it must satisfy the following condition. Number 1, it must be in 1NF. Number 2, no partial dependency. Every non-key attribute should be fully dependent on the entire primary key, not just part of it. This rule applies primarily to tables with composite primary keys. Example of second normal form is, consider the following table that is in 1NF. The order ID, product name, quantity, and the supplier name. The problems with this table is that the partial dependency. The product name and the supplier name depend only on product ID, not the entire primary key, which is order ID and product ID. This violates 2NF. Converting to second normal form, to bring the table into 2NF, we separate the data into two tables to remove partial dependencies: order table and the product table. No partial dependency in the order table. Quantity is fully dependent on both order ID and product ID. In the product table, product name and supplier name are dependent only on the product ID. This ensures that each non-key attribute is fully dependent on the primary key, bringing the tables into 2NF. Let's now talk about the third normal form, 3NF. For a table to be in third normal form, it must satisfy the following condition. Number 1, it must be in 2NF. Number 2, there should be no transitive dependency where non-key attributes depend on other non-key attributes rather than the primary key. Let's check out the example of a third normal form. Consider the following table that is in 2NF. The problems with the 2NF table is that the transitive dependency. The instructor name is dependent on the course name, which is not directly on student ID or course ID, and this violates 3NF. So how do we convert this into 3NF? To achieve 3NF, we split the table to remove the transitive dependency. Student course table and course table. No transitive dependency. Now, the student course table, there are no non-key attributes depending on other non-key attributes. The course table stores the course and instructor information separately. This structure eliminates transitive dependency, ensuring the tables conform to 3NF. Let's now talk about the Boyce Codd normal form, which is BCNF. BCNF is an extension of the third normal form, 3NF. A table is in BCNF if it is in 3NF, and for every functional dependency, A implies to B, A should be a super key. Let's check out the example of a Boyce Codd normal form BCNF. So you can see this table here consisting of employee ID, department, and the manager. The problem with this table is that the BCNF violation. In this table, department determines manager, but department is not a super key, since employee ID is the primary key. This violates BCNF. So how do we convert this to BCNF? To achieve BCNF, we split the table to ensure that every determinant is a super key. As you can see, the employee table and the department table. The super key requirement in the employee table, employee ID is the primary key, and in the department table, department is now the primary key. The decomposition ensures that every functional dependency is satisfied by a super key, meeting the requirements of BCNF. Let's now talk about the fourth normal form, which is 4NF. A table is said to be in 4NF if it is in BCNF and has no multi-value dependencies. So let's consider an example of a fourth normal form. Consider a table where an employee can have multiple skills and work on multiple projects. As you can see, the employee ID, skill, and the project. The problem with this table is that it is multi-value dependency. An employee skill is independent of the project, but both are stored in the same table. This leads to multi-value dependency, violating 4NF. So, in order to achieve 4NF, we separate the skills and the projects into different tables, the employee skill table and the employee projects table. And now you can see that no multi-value dependency. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the table conform to 4NF. Let's now talk about the fifth normal form, the employee skill table and the employee projects table. So as you can see that no multi-value dependency is there. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the tables conform to 4NF. Now let's talk about the fifth normal form, which is 5NF. A table is said to be in fifth normal form if it is in 4NF and cannot be decomposed into any smaller tables, losing information, also known as joint dependency. Let's consider an example of a fifth normal form. This is a table here that records the relationship between suppliers, parts, and a project. The problem with this table is that the joint dependency. The table has a complex relationship between suppliers, parts, and projects that can be decomposed further. So how do we convert this into fifth normal form? In order to achieve 5NF, we break the table into smaller related tables, the suppliers part table and the suppliers project table, also parts project table. Eliminating joint dependency, by decomposing the table into 3 smaller tables, we remove the complex relationship and eliminate the joint dependency, ensuring the tables conform to 5NF.
So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright. So this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause, or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee. From my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select, I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than, I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with 2 different tables. So suppose you want to display some information that are present in 2 different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using 2 tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay, now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay, so first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write ampersand ampersand. Next I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was double ampersand. Next I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top_players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top_player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top_players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL_IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records. So I'm using this limit keyword and my variable var, which I created here. I'll end my select statement. I'll end my stored procedure with / and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is sp_sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is sp_sort by salary. The other two were top_player and top_players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is sp_sort by salary. And inside this I'll give my parameter, which was actually VAR, and this VAR we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /, then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in two parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says one row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore EMPs, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter to / I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female, I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp underscore details. So I've used my out parameter and I'm creating a new variable called total underscore EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total underscore EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure, sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets, I'll pass in the parameter as @f underscore emp. I'll give a semicolon. Then I'll write select @f underscore emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure, and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now, there are mainly three types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we will learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting if any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. age is 13, the name is Dave, and let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. I'll give this as a comment. Okay, now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is I'll write create view followed by the view name which is cust underscore details. Then you write as select. I'm going to select a few column names from my original customer table, which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright. I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name that is cust underscore details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that I'm going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside classic models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there's some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name, that is product underscore description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table, I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay, so here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay, now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cus details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be Okay, so instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that, you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright. Now moving to our final section in this demo. Here we will learn about Windows functions. Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay. I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DPT, and I'll give an alias as total salary so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright. Now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num, give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name. which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values. I'll give 101. The name is Shane. Give a comma. I'll insert the second student name 102. The name is Bradley. I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Herath. I'll give a comma. I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over within brackets. I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, if you see here, there is just one student in the name Shane. We have one student in the name Bradley, but here if you see for Herath, the second record it says 2, which means there are two records for Herath, and if I scroll down there is one record for Nathan and there are two records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when two or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable that is var underscore a as an alias name, let's say test rank, from my table that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function has assigned the same value which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column that is salary descending. I'll give an alias as highest underscore salary from my table that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function that is first underscore value followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial So let me just scroll through and show you what we did from the beginning. First, we learned about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database, which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures, in operator or the in parameter, as well as the out parameter in stored procedure. After stored procedure, we learned another crucial